It's not a coincidence that the first atomic bomb detonation on Earth by human beings was done not far from where Roswell is in New Mexico, where this crash that occurred in 1947 with alien bodies and alien spacecraft and so forth. Many of these phenomena do occur on military installations to this very day. These people aren't they worried about like encountering these phenomena? If they're really seen every day, as Ryan told me, they're seen every day, and people report cubes and spheres or spheres and cubes. There's a psychological component that's fundamentally not scientific. It doesn't mean that they're wrong.
Keating, you made it to New Jersey. Thank you for coming out here, sir.
First time here in a while. It's good to be back. Good to be back on the East Coast as a New Yorker. It's always a little bit of a danger going to New Jersey, but for you, I brave it, my friend.
Well, it's a lot easier getting you to New Jersey than Florida. My boy Danny Jones has been trying for 18 months, so we beat him to the punch.
I'm going to see him. I'm seeing him right after I see our mutual friend Jordan Peterson and Peterson Academy coming up soon.
Oh, what are you doing up there?
So Jordan's starting this university to kind of combat both the excessive high prices, the kind of insane campus politics and so forth. So he's asked a couple of faculty members to join and to present courses on their subject matter expertise. It has nothing to do with politics or ideology whatsoever. It's completely neutral. I'll be teaching about cosmology, and there's not too much. We have our big bangs in cosmology, but we're not going to be talking about woke versus Antifa, and no, that's not what my goal is. So it's going to be an interesting experience. So he has a whole studio there he built with it's really his daughter Michaela.
It's in Miami?
It's in Miami, yeah. Yeah, so I'll be there, and then I'm gonna catch a ride across the state to the Pan. I've never been to Tampa, so I'm gonna see our mutual buddy Danny boy. I can't wait.
Tampa's fun. Tampa's a good town.
Is it?
Don't have too much fun there. Anyway, you didn't hear that from me. But right. Yeah, I had connected with you back in May, and now since we put this on the calendar, you blew the up because you went on Joe Rogan.
That's right.
The GOAT scoops me once again. He's never scooped me
Well,
before,
all you need here is an archery range and a couple of life-size werewolves and a picture of Klaus Schwab over the toilet. And you've got Austin Scoop, my buddy. You're on your way. Your trajectory. You look at Joe. He's saturating. You're still rising.
He's got a Klaus Schwab picture above the toilet.
Yeah. So you're holding your business, and you're doing your business, and you're looking into the cold, beady eyes of
I don't think
Klaus
I could piss.
Schwab.
I don't think anything would happen. I'd be a little
I don't know.
freaked
It's
out.
like, is it the old age? Is it my prostate, or what's going on? Oh no, it's Klaus. It's these cold, dead eyes of the World Economic Forum looking at me.
Yeah, that's a whole. If we go down that rabbit hole, we'll be there all day. But we got things to talk about.
That's right.
But I had connected with you because I had Michio Kaku in for the podcast. I recorded with him at the end of April, and so when that came out, I did a little mini documentary that's still on my channel now, just covering kind of like the 8.5-minute response within the podcast that Michio gave to your friend Eric Weinstein's criticism that he had for Michio a few months before when he was on Joe Rogan. And here's the context there for those of you who aren't familiar.
If you can't stand the heat, get out of the kitchen. And to be in the heat means, to be criticized.
Well, you and I were looking at a video right before we went on camera. I wanted to show you in case you didn't have the context, but we were watching a video of Eric Weinstein on Joe Rogan recently where he was, I guess, like having a moment with string theory and going off about it.
David Grusch and Ed Witten should be in front of the community explaining, why did you take all the smartest people, all the resources, all the attention? Michio Kaku, get Michio Kaku in here with me. Michio Kaku is out of control. Sean Carroll is covering up for this as well.
In what way?
They are too kind. Brian Greene. Like, I had this interchange with Brian Greene where I said, we're not being honest about the failure of string theory. And Brian was like, oh, well, maybe we were a little bit exuberant. And I blurt out, Institute for Arts and Ideas, I blurt out, that's like saying Milai. My was irrational exuberance. No, you put a lot of people's careers in the shredder.
And for people that aren't familiar with that, I'll let you explain the details. But we'd gone back and forth, and I felt like, first of all, it would be really cool to see Eric and Michio in a room, and I hope if that happens, it's you who does it. That would be really, really cool. But the core of that argument was over, of course, string theory, which Eric has presented his own theory, geometric unity, and string theory is obviously heavily debated within the science world because it hasn't been proven. But I guess where we stand almost 50 years since string theory was invented, where are you on that issue? Do you think it's something where we need to move past it now because it hasn't been proven and can't be tested, or do you think it's a matter of it just has too much of like a little bit of an iron wall around it, and we should be looking at other opportunities as well?
Yeah. Well, you asked a lot of good questions there. So I'll start with the original kind of statement about Michio and Eric. First of all, you have to realize it's kind of surprising that in this very relatively arcane, abstruse, abstract form of mathematical physics, that there are battles every much as intense as the East Coast, West Coast rap battles of the 1990s that you probably don't remember, but I do.
Oh, I know all about those.
Biggie and Tupac and there you go. That's right. Not far from here, and then where I'm from on the West Coast. And so literally we have East Coasters, Ed Witten, Michio Kaku, and then we have the West Coast gang out there with Eric and others taking an alternative approach. So it's surprising that there's so much heat and passion that's generated behind it. And partially, I think the reason is that mathematics has always held a special status in the culture. Mathematics is part of culture. It's not divorced from it. It's not some thing you use as a tool to do something else. In and of itself, mathematics has a power to captivate the mind. And I think mathematicians and so forth are some of the most respected people in the world for their brilliance, for their intellect. And so it's a very different subject from almost any other subject in that things in math are not necessarily real. In fact, I interviewed a young, she has a PhD in math, but she's not a professor, named Eugenia Chang, and she has a book called Is Math Real? Basically, does math exist? So I always say, can you give me a triangle? No, but you can think about a triangle. Can you give me a complex number? No, but we can think about a complex number. Can you even give me infinity? No, but you can think about infinity in ways that computers can't even do it. So there are these things that are purely products of the human mind. And I think the pinnacle of the human mind is mathematics. And it is the basis of all the physics and so forth that I do. Now, I'm an experimentalist. I build instrumentation. My goal is to see not if these people are right, but to prove them wrong. My job is to be the exterminator of their theories. There's no such thing as a proof in physics.
Hey guys, for the month of October, 72%, just under, it was about 71.6% of our viewers were not subscribed. If you could take 2 seconds, less than 2 seconds, really like 1 second, and smash that subscribe button as well as that notifications bell, we're gonna have a better number there. We'll be able to get into the algorithm more and continue to get great guests and even better guests as we move forward. We got some awesome people coming up throughout the rest of December and January, including a return from a fan favorite, Matt Cox, as well as Joe Tedeye and Matt LaCroix, and a lot of new people as well who you're going to love. So hit that subscribe button, smash that notifications bell as well, and enjoy the rest of the show. Thank you.
So you mentioned like because we don't have proof or we can't be proven. Nothing in physics can be proven. We can't prove there was a Big Bang. I can't prove there's not a purple unicorn on Uranus. I mean, there's no way to falsify every statement that you could make about physics. It doesn't make it scientifically accurate. But mathematics, you can. So in other words, you can determine what is property of mathematical purview. In other words, what is kosher, what is acceptable, what is part of the project of mathematics, because it can be proven or falsified. We may not be able to do it. It took famously 300 years between Fermat, coming up with this last theorem where he put it in the margins of a little paperback that he was reading at the time before it was proven by Andrew Wiles, not far from here in Princeton, New Jersey. And so you think about things that can be proven, it gives physicists a little bit of envy because we can't prove anything in physics.
I was going to say, you don't really have it. It seems to me like even when you look at some of the core tenets, like people will talk about gravity. Well, that'll probably never be disproven. Do we know that, though? You know what I mean?
Yeah.
Because think about how short human history has even been to this point and how much is out there that we have no clue about. Like gravity, for all intents and purposes, could be in an entirely different, like, I'm gonna make up a term here, but like dimensional wavelength than we understand it. No.
Yeah, I'm not. We don't talk about dimensional wavelengths, but we will talk about kind of an analogy. Imagine you put every theory that every physicist has ever had onto a ping pong ball, and you put it into a big 55-gallon oil drum, okay, and you just pull them out. 99 out of every 100 of those ping pong balls would have a theory that was proven to be wrong, provisional, incorrect. And I think now it's no different. Maybe it's even worse because it's never been easier to theory is like software. You know, it's easy to generate a lot of software and say, I'm going to go back. It's called technical debt. You know, I'm going to go back and fix up these lines in the code. I'm going to document. Famously, I don't know if you ever wrote computer code. I'm terrible at this.
Never did.
I love to write it. Super fun. But you're supposed to document what you're doing so that somebody else can come and do some post-mortem analysis on why you have this bug that led to $10 billion of Alameda coin to drop to zero or whatever, right? So you should document it. I never do it. So that's technical debt. I'm going to go back and do it. So it's easy to produce it and forget to do the documentation, to do the technical debt that you're supposed to do. But experiments, it's not easy to make an experiment. I'm part of the leadership of a $100 million project in Chile called the Simons Observatory that's taken almost 8 years to come to fruition to get its first photon from the universe. And it's not even a photon from the Big Bang. It's a photon from the planet Mars. It's nothing that you would write home about. But that's how long it's taken, 380 people, 7 years working on. So you never do it's not easy to produce experiments. It's very hard. That's why every experiment, in my opinion, should be decisive. It should have a clear-cut goal on what it's going to do. Because we never know. We serve at if we were living in Ukraine right now, are we living in Israel or Gaza? Like, we wouldn't be doing physics. I wouldn't be doing. My colleagues wouldn't be doing physics right now. We'd be scared for our lives, trying to figure out how to survive. The other thing we'd be doing is probably working on a military project somewhere. A physicist would be working on some military camp, and this is true throughout history. Physicists have always worked hand in hand, or astronomers with the military. And so what's been really interesting to me is to see that we only get to do this. We serve at the pleasure of peaceful circumstances. We do some of the most esoteric, as I said, arcane, abstruse things that you can do that actually serve no purpose. Like what I'm doing, $100 million. You could put that to cancer research. You could put that to, whatever you're saying. And maybe it would be doing more good. Maybe it wouldn't. Or food, just buying food, I guarantee, or mosquito nets. It would definitely do more good ultimately. But sometimes I think that's what we should be doing. Because things that have no quote unquote purpose are what make human beings human and distinguish and different. Animals provide for their kids, and there's even some notion of altruism in the animal kingdom, as Steven Pinker and other people will tell you, right?
Yeah.
So the question is, what makes us uniquely human? It's doing things that are useless to benefit. And it's not going to make a faster, although cell phones did come out of the research in radio astronomy that not that I did, but the legacy that I'm, heir to, created the technology right down the road here in New Jersey, in central New Jersey, in Homedale, at Bell Labs, the technology that you're carrying in your pocket, right? Yeah. And that was concomitant with the discovery of the origin of the universe via the cosmic microwave background radiation that I study. So getting back to your first question, these guys are doing stuff that's very important, but it may not be very significant. In other words, we may never be able to have evidence for it. Now, just because we don't have evidence, so I don't have evidence for a supernova, what blew up and created this little piece of meteorite that I gave you.
Oh yeah, cool.
As gratitude for hosting me. And I give it all out to my visitors on my website. You go to briankeating.com. I give those away.
4 billion years old.
4 billion years old, and I'll send you the information about it when you join my email list. You get the assay, the chemical composition, you get the origin, and you get also a guide on how to see meteor showers, because I think that's super cool. And you can see them here, even in the middle of Manhattan. Yep, you can see
New
them.
York.
You can see meteor showers now, and it's not going to be as good as if you come to the dark desert of California, where I live. Yeah, so it's going to be a lot better when you come and do my podcast. We'll do it in person with you. You made me come up to New Jersey. I'm going to make you come to
I'll be there. I will be there.
So anyway, we can look for things that we can't we can see the indirect evidence for things that we can't witness. That supernova produced that chunk of meteorite. That chunk is the byproduct of a fusion reaction that terminated when a star could no longer support its girth, its mass, and the pressure that was felt succumbed to a nuclear fusion event that then catastrophically exploded that star out into the universe.
How do we date something like that?
Well, you go to Tinder. That's the only dating I used to be. No, so these are dated by their composition, their isotope ratios, and also the fact that they can be determined to have the same metallic origin. We compare with a model for how these stars form and then they end their life. So there was a star in our neighborhood of the Milky Way galaxy that predated our Milky Way galaxy. And when it got to the end of its life, when it started to fuse heavier and heavier elements together that no longer gave off enough energy to bloat out the star anymore, to keep the pressure needed to counteract the gravitational force of the outer layers of this onion-like star, the last thing it produces is called iron and heavy elements. And that's why this thing is so dense, and you can verify it's so dense. It's also magnetic. You can stick it to a magnet.
This is magnetic?
Yeah, it's highly magnetic.
Wow.
Yeah, if you had one here. If you have a magnetic bobblehead, maybe that.
I don't.
Yeah, we got to get you one.
I got to test that.
So, and the exact composition of that meteorite is found in our Earth as well, and as well as in the rocky core of our planet and the other inner rocky planets. So we can date that they came from the same supernova. So the death of another star provided the impetus, the material, the raw ingredients that made our planet, and also is then found in the crust of our planet. So there's iron inside of the crust of the Earth that came from that same supernova that produced that iron chunk right here. And some of that iron made itself into wheat and so forth that your mother ate when she was pregnant with you, and eventually your body synthesized into make hemoglobin. So the hemoglobin molecule that fixes air, that basically allows you to live and breathe as a breathing individual, that iron came from the same meteor that came from the same event that produced that. Now, we didn't witness any of that. So why am I saying all this? Because we also can't witness like what's happening in 10 to the minus 30th meters in a vibrating 10-dimensional superstring, right? That's not something we can have access to. But we can infer from the downstream effects what these models would predict for things that we haven't seen. So if I see that thing there, and I say that same model predicts that there should be an isotope ratio, if what I said was not a lie, okay, that the iron in your blood came from the same supernova explosion that produced that meteorite, then I've just made a testable prediction. You can test the isotope ratio in your blood, and it won't be pure iron 56 or whatever it is. It'll have some isotope ratio, and it'll be the same as that. And that came from space. That was witnessed. The fall was witnessed. It came from Argentina. You'll learn all about it when you click on the link in my newsletter. And that has a chemical assay, and it's very, very similar to the chemical composition in your body. So that's a model prediction. Now, string theory, the question is, can it predict anything?
You're doing my job for me. I love it. You're great.
Well, I've learned a lot from you. You've actually helped me grow the Into the Impossible podcast. 100,000 subscribers in less than a year. Yeah.
Your channel is still, by the way, I will have all your links in our description. Your channel, in my opinion, is still massively underrated. I mean, the people you're getting on there.
Yeah.
I mean, you're so connected in the field, but it's incredible.
Yeah. It's been, they say like when you get to the top of the mountain where you're closer to than I am, or, someone like Joe or something like Joe Rogan, who's a wonderful, I call him, the biggest mensch in the business. He's influenced so many of us, right? And he gives us kind of a target to aspire to.
Yeah.
And when I was on the podcast with him, I asked him, like, what are your goals? Because I was like, you're always asking everybody else, like, what are your goals in the podcast? Like, what do you want to do? And where is your kind of promised land for where you want to go? And he was just like, I have this life that's like a life by design that allows me to not necessarily have freedom to do anything. Although he does, it's a comedy story. He probably flies private. He does whatever. But he has freedom from... He doesn't have a boss. I mean, he advertises stuff that he makes. Like, it's not like, oh, well, like, I don't know who your advertisers are. I saw some powders out there. I don't know if I should mention them or not.
Don't mention them yet.
I won't mention them. Okay, fine. But there's some delicious stuff out there. But like when I have an advertiser, I have to do it. And then the sponsor comes by, oh, you misplaced the, kind of product placement. Or my favorite is you were supposed to log in to this link that, is where our people are going to access. I'm like, the content's still there. Like, why do I have to log in? And they're like, well, someone might see that it's like Brian Keating or not Brian Keating. It's just like new user. Oh my God. So I'm like, thanks. Now I have a boss.
This is what Ari has to do for you. You should tell him to take care of it.
I know. Christ. I love Ari. Hopefully we'll see him. But the bottom line is when you have something that makes predictions, the more powerful a scientific theory is, the more predictions it can make. And the more retrodictions it can explain. In other words, it can explain things that used to happen. You asked me about gravity.
Yep.
So will we ever know that gravity has been overturned or we were wrong? I suspect no. And the reason is because we know it's already wrong. It's wrong in a certain sense. When we say that something is a scientific fact, let's say I say, do you believe the earth is round?
Yes.
Okay, well, you're totally wrong. If I say to you, is the earth flat? You'll say no. You'll be right if you say no, right?
But we have proven that though, because it's here.
Okay. So the Earth. Now I'm going to go into professor mode. Okay, this is
Please.
My wife loves this. So the Earth is not a perfect sphere.
Right.
It has some spherical properties. It's actually pretty oblate. It has properties like a pear.
But it's not flat.
It's not flat. So if you said it's flat, you're wrong. And if you say it's a sphere, you're wrong. But as Isaac Asimov said, you're less wrong if you say it's a sphere than if it's a flat, if you said it was perfectly flat. Now, what does that imply? That means that there is some perfect description. And even if I said it's pear-shaped, I'm also wrong. But it's getting closer and closer to the scientific truth. Science is not about saying provable facts. Again, we can't prove that the Earth is a prolate spheroid with these spherical harmonic contributions, that distortions at this 0.01% level, the way that I can prove 2 + 2 = 4, even though that'll take 400 pages of abstract mathematics to prove that simple sounding statement. You can't say, oh, well, you have one finger, you have two. No, that's not what we're talking about. The actual mathematics behind proving 2 + 2 = 4 is significantly advanced. It's not basic mathematics like I teach to a 5-year-old. But there is no such thing as proving physically that the Earth is a sphere or a pear or whatever shape you want, a donut. There is no way to prove that. Scientifically, all we can do is say something is wrong. But what you should do is say things that are accurate as much as you can with precision. So let me talk about the difference between accuracy and precision. If I say you weigh less than 1,000 pounds, I mean, you've been going to the gym. You look pretty diesel, buddy. But you definitely do. That's accurate. Right? Is it precise?
It doesn't tell you anything.
Absolutely correct. It is not precise. So you want to have accuracy and precision. So I want to say the Earth is not a sphere. Then I have to add some terms to it. That makes it more precise, but it's still not perfectly accurate. So you want to try to convert. Now, my question, and I think what Eric complains about people like Michio Kaku, is that he'll say something akin to, you weigh less than 1,000 pounds. And he'll say, isn't this great? We now have a scientifically testable, fact that, okay, so I actually had literally one of the fathers of modern string theory. His name is Kamran Vafa. He's a brilliant man, wonderful mensch of a guy up at Harvard. And he was on my podcast, and he said, no, Brian, it's not true that string theory doesn't make any predictions. He basically said, no, string theory predicts the mass of the electron. And I was like, I didn't know that. That's kind of news to me. What is it? What's the prediction? First of all, it's not a prediction. It's a retro. We already have the measurement. So now he's saying, where does it come from purely mathematically within the confines of the limitations of string theory? He said, yes, we have limits on it. I said, obviously, you're not going to say it's exactly 10 to the minus 28 with 65 decimal places behind the 28. No. But he said it's greater than, effectively, it would be like saying you weigh between 1 kilogram, and 10 to the 30th kilograms. Except it's put a negative sign.
Wide.
Yeah. But look, what could those numbers be, Julian? What could possibly be? Pick a number. What is the range of those exponents? It could be anything from negative infinity to positive infinity.
Yeah, numbers we can't concept at all.
Exactly. But not only that we can't concept, so actually it's a very accurate thing within the broad range of all it could be from negative infinity to positive infinity, right? So it's actually very accurate, right? Just like me saying you between 0 pounds and infinity pounds. Okay, so I put 1,000 kilograms rather. That's very accurate compared to what that could be the space. So that's why I think people like Eric and people like me, to be honest, I won't speak for Eric, but for me, get frustrated because when we hear other theorists talk about this, I get very upset because I think that their job is very envious. They get to literally think. They don't necessarily have to travel to Chile and deal with dumping concrete in the wrong place and getting electricity. You think it was hard to set up this beautiful studio? Imagine doing that 17,000 feet, wearing a hard hat, oxygen mask, steel-toed boots, wearing a life-saving vest in case you fall over and die, getting checked for all sorts of high-altitude sickness and diseases, having to pass a physical exam. Versus sitting in your office. Yeah, sitting in your office and, living the life of the mind. Now, when you ask those people, when I ask Sabina Hassenfelder or I ask Stephen Wolfram, and I say, well, what do you think about Eric's theory, or what do you think about Stephen's theory to Sabina Hassenfeld? And they'll say, oh, I don't have time. You don't have time. Like, what else are you working on? I mean, she's got a thriving YouTube channel, and she's that's great. That's her job now, and she is doing research, and she's to be commended for it. But she's not a professor. She's not doing it, and neither is Stephen Wolfram. He's not a professor. I mean, he owns a business, and he's very good at what he does. But to say I don't have time, all I have time for is to look at my own theory and kind of verify. That would be like me saying I'm going to ignore these other experiments that actually saying, Brian Keating, you saw dust. You claim to see the origin of the universe. You saw dust. You're a fraud. You're a charlatan. If I just did that and I didn't listen to the critics, that would be pathetic. And yet I do feel like there's an unwillingness for these theorists to spend a couple hours.
You're referring to your bicep.
That's the bicep experiment.
Got it. Yeah. Okay. Yeah. But do you think part of that, and by the way, I don't agree with this, but do you think part of that is a little bit of that ivory tower of, well, the guy you're talking about with Eric Weinstein he's a mathematician. He's not even a physicist. So they don't want to, quote unquote, waste their time with it.
They know
you don't think that's it?
No, Eric's a dominant, force in the intellectual sphere. No, I don't think that's true at all. I'll get frustrated with him because he'll often say, "Oh, I'm just a mathematician," but in reality, I mean, he's claiming to impinge upon the traditional pathways of modern physics, including that of maybe pre-discovering certain even foundational equations that have led to, the so-called string revolution and other things while he was a graduate student. And there's documentation about this from his thesis. No, he traffics in physics. It's just highly mathematical physics, which is fine. I mean, mathematicians or physicists have been contributing to mathematics since, long before, Alexander of Samos and, there's or Aristotle. There are, obviously Isaac Newton, discovered calculus or invented calculus, depending on how you think about it.
Significant overlap for sure.
Yeah.
Huge part of it. But if you had to explain to like the layman out there to get at the core of what we've been coming around to with like the Kaku camp and like the Weinstein camp, like what is string theory in your estimation, and what is it that Eric is proposing with geometric unity?
I think there's a misguided fascination, focus, obsession in some sense with string theory. String theory has gotten a tremendous amount of attention, and this is sociological, perhaps, and possibly because of the authority bias that's always present when you have a field. As there's no telling how much respect people have for mathematics and physics. And I'm talking about intellectuals. There was a famous Japanese poet who won the Nobel Prize in Literature. And he told his mother, and his mother said, well, that's great, but I always thought you'd be a physicist. She was disappointed. Like, he's one of, 100 people still alive or even fewer, right? So you think about, like, what is the pinnacle of human brain power? It's typically a mathematician, and I'm not a mathematician. I'm not tooting my own horn. I'm an experimental physicist, which is several levels down in the public's estimation. Who do you know as a physicist? Well, just around the corner, Brian Greene, Jan Levin. As I said, Stephen Wolfram, Stephen Hawking, the names that people know, Lenny Susskind, all these people I've had on. I've had 14 Nobel Prize winners in physics alone on my podcast, plus several others from other disciplines. They're almost all theoretical physicists, which is as close to math as you can get in physics. What I feel is missing from all these discussions, from all these theories, is a recognition that they are, for some reason, putting the cart before the horse. Or in my case, I call this the toe before the gut, and it's a hilarious pun. Trust me, Julian. So there's something in physics called unification. Unification is a recognition that seemingly disparate phenomena, like electricity, lightning bolts, static cling, and what have you, and magnetism, the stuff of refrigerator magnets and levitating trains, that those are actually two sides of the same coin, called electromagnetism. And they're actually different manifestations. And this is a key insight in Einstein's special theory of relativity. It was understood by James Clerk Maxwell, who laid the foundations for modern mathematical physics of electrodynamics and many other things, that actually an observer in motion, so let's say you see a charge here. There's just a static charge. It's just sitting there. You and I see it. We're static, and we see it as producing an electric field that radiates away from a positive charge or converges on a negative charge. That's convention, right? And yet, if you have somebody sliding by on a train, down the street, they will see that charge in motion. How do you reconcile those two things? And by the way, a charge in motion produces what's called a current. Currents are the sources of magnetic fields. So how can you reconcile those two things with the statement that motion is relative? There's no such thing as absolute velocity. You and I can't say that someone in a car, and you've had this experience, you're sitting on a train at Penn Station, the train next to you starts to move, you're like, oh, we're moving? No, you're not moving, you're stationary. No one can tell when an observer or a participant is in relative constant motion. They can't say that you're in relative constant motion. They can only say, according to me, you're in motion with some velocity in some direction.
Are you talking, I want to make sure just for people who are following, are you talking about the difference in what I can see if like you physically saw me running versus me sitting on the train and you only saw me sitting on the train, you didn't see the train itself moving?
At constant velocity, it almost doesn't make a difference. If you're carrying a charge, then somebody running at the same speed as you would see that charge being static and therefore only producing a static electric field. However, me sitting on the ground, lazily sipping my delicious coffee, I would see you moving with a charge, therefore you'd be producing a current. Therefore, I would see that you're going to produce a magnetic field, not an electric field. There would be no electric field, there'd be an electric magnetic field. What Maxwell realized is that those are two sides of the same coin. Electricity, one man's electric field is another man's magnetic field. Okay? So what's so important about that is that there was a unification. They're actually one thing. Call it the electromagnetic field.
When did he come up with that?
1850s, 1860s. Okay. He died very young, like 40 years old. And then even he, as brilliant as he was, he thought that these waves traveled through a medium called the ether that was rejected 50 or 60 years later. But essentially, he didn't understand how you could have a wave of light or electromagnetism, which he also discovered. How could you have a wave traveling through a vacuum where there's no medium? There's no such. We're talking now. There's sound waves emanating from pressure and density perturbations that get picked up by a little diaphram.
Pressure and density what?
Variations or vibrations. Yeah, perturbations.
Perturbations.
Yeah, perturbations.
Like, what the fuck is that?
That's some of the things you can't. That sound dirty, but are not. Yeah. Okay. I'm gonna go perturbate myself later on. So when you think about how these things are two sides of the same coin, the same thing exists with nuclear physics and particle physics and quantum mechanics. There are people that say there are four forces of nature. There's electricity and magnetism. That's one force. Now, it used to be two forces. Now it's one force. There's something called the weak nuclear force. This is responsible for radioactive decay. So when a neutron decays and shoots off an electron, a neutrino, antineutrino, and a proton, those objects are part of what's called weak nuclear decay. Okay. Then there's a strong force of electromagnetism. A strong force of the nucleus, which is responsible. You ever think of like, how does I don't think most people think about this, but helium has two protons in its nucleus. And
never thought about that neutrons. In my life.
You never get. Well, we're going to see the Macy's Day Parade soon. So when you see the helium balloon, think about the fact that helium has two protons in its nucleus.
Okay.
What do you know about like charges, Julian?
Not much. Assume nothing.
Like charges repel. What do you know about opposites?
Oh, I thought you said light charges.
No,
not
like.
Okay.
Like.
Yeah, they repel. Opposites attract.
So how does this how do these two protons stick together? They're both positively charged.
We would have to break that mold.
Well, you'd have to have some other force that's stronger than the electrostatic repulsion between two like charges. And that's called the strong force. It indeed exists. Then there's the fourth force, which you're very familiar with because you're jacked, right? That's called gravity. So you're working against gravity. You go to the gym, you do The question is, can we unify more of those forces? So we already unified electricity and magnetism into one force. So we basically reduced 5 forces to 4 forces. Then they reduced another force in the 60s and 70s. One of my past guests, Sheldon Glashow, inspiration for young Sheldon on the Big Bang Theory.
Oh, shit, really?
Yeah. So he's a Nobel laureate up in Boston. He and his colleagues, Steven Weinberg and Abdus Salam, they invented a way to unify together the weak nuclear force with the electric and magnetic force. And that's called electroweak theory. So now we've reduced 5 forces down to 3. Electroweak, and then gravity and the strong nuclear force.
Okay.
Now the question is, can you unify the strong nuclear force with the electroweak force? That's called grand unified theory. If those were shown to be the manifestation of one single force, then you'd have 2 left. Guess what we'd want to do next? Unify a strong plus electron weak with gravity. That's called the theory of everything. That, in some sense, is the unification that Eric attempts to achieve and that string theory attempts to achieve. So they're trying to achieve the ultimate unification. But wait, there's a problem. It would be like we built the second and third floor of this penthouse apartment here, but we never built the basement or the first floor. In other words, we have not yet come to an agreement or any testable theory for what's called grand unification, abbreviation GUT. So I always joke, back to my hilarious joke.
Yeah, the toe before the
They're
gut.
putting the toe before the gut. And I do that on a scale because I can't look down. But but if you look at these phenomena, why is there an obsession with this? And I think it's because of what your past guest, Michio, said. If you could get this equation, perhaps 1 inch long, I'm going to try to channel Michio.
Perhaps 1 inch long. It could take you to the top.
You would then have known and knowledge of the mind of God.
Yes.
That's why he calls it that. But wait a second. How can you know the mind of God if you don't know his like pecs and his cranium? Because you don't have the gut. You don't have the gut, Michio. So why are you doing that? Why? Because what did he say inspired him the most? On this very chair, in this very type of studio when you were
Einstein.
down. He said Einstein. He said when he died, he noted that Einstein had on his desk a piece of paper and he was working so hard and it was to come up with this theory of everything. It's not really what he was doing. He certainly wasn't doing string theory.
That's what he was referring to it as.
Yeah.
More than anything.
Yeah. I mean, it was his holy grail, his promised land. And Michio wanted to not take over. Well, we don't have a grand unified theory. If Michio had come up as an age, whatever he was when Einstein died, I want to be a theoretical physicist and understand how to unify together the strong nuclear force with the electromagnetic force, he would have won probably multiple Nobel Prizes and also did what Einstein didn't do. But because of this allure of being the next Einstein and so forth, people like him and others have built up people like Ed Witten into these superhuman intellects that almost too much is invested in for it to not be right.
And
there's no evidence for it.
That was the guy that Eric was in that same sit down with Joe Rogan when he talked about Michio. Witten was the guy who he was like, I am so intimidated by this man. He's so smart or whatever. But he hasn't.
He's Voldemort.
He's another guy who's smack in the middle of defending string theory.
Well, he's one of the foremost, progenitors of one of the closest and key insights of string theory, which is originally the string theory had 26 dimensions. I would say,
can we break it down for people?
So string theory is a mathematical conception that attempts to do a unification of quantum mechanics, which is the theory of the atomic world in the realm of the electrons and protons and the electrons and neutrons and so forth, and their constituent particles, including things like quarks, and then combine them in a unification schema to make them compatible with gravity, to have a particle of gravity effectively that acts on the space, this very esoteric mathematical space. And for technical reasons, you can't do it in the ordinary world of three-dimensional space that you and I love and enjoy, combined with time. So time plus space is called space-time. It is a network of points, mathematically, arbitrarily speaking, that there's not enough space, so to speak. There's not enough degrees of freedom to have all the particles come together and manifest a gravity with the particles of charge, electromagnetism, the particles of the weak force, and the particles of the strong force in 4 dimensions.
So they go below it. They go a layer.
They go above it. They say actually the space in which things are happening is not 4-dimensional. We see 4-dimensional space, just like we don't see the effects of protons, neutrons, and electrons.
Okay, yeah. Continue.
But we will see the macroscopic manifestation of particles. We see their collective behavior. We can't see their individual behavior. They will say you can't even see the individual behavior of the dimensions because they're so much smaller. Their size scales in which they operate are so far removed from our observability.
That's what I was talking about.
Yeah.
Go lower with the size.
Yeah, exactly. Right. Yeah. So you're effectively talking about what are different schemes called compactification and so forth. So you have more than the 4 dimensions. Now the question is it 5 dimensions? There were theories. In other words, you could have a theory that would have quantum mechanics and magnetism and electricity, and that actually could work in a certain sense if space-time had 5 dimensions. So if you added one more dimension, it's you'd have like an electromagnetic dimension, and you can almost see this with things like there are birds, or here's a good thing, like there's three properties to light. Like we're in this room, there's a certain color of light, there's a certain intensity of light, and there's something called polarization, which is the least familiar property of light, which is how the waves of electricity and magnetism are marching up and down, left and right, or not at all. Okay.
Yeah, I never thought about that building this.
Yeah,
thought about the first two.
Exactly. It's totally unfamiliar because we don't have sensors to detect that. Bees do, and there's certain crystals that can have the sense, and birds do. So they can navigate. There's certain navigational properties that nature has embodied them to evolve to have, such that they can navigate using the not just the color and intensity of the sun, but actually when the sun is down, they'll be able to navigate based on the polarization of the light waves. But anyway, if you add another dimension, our eyes to our eyes capability, and actually then we could see this phenomena, it would be like, we're adding an extra dimension to space-time. So we'd have super, what do they call that? Extrasensory perception, sixth sense. So we don't have that. And technically, there's a tiny amount in certain people. But anyway, the average person doesn't have it. So when you think about what they had to do, they had to say, well, what is the minimum number of additional properties of the universe that you'd have to add such that it could manifest the properties that you do want, which is to have quantum mechanics and gravity play together nicely and all operate as one single equation, one single force field. And that was found to be originally 26. You need 26 different dimensions of space, and then these abstract spaces that we can't, by definition, access because we exist in 3 dimensions. And even particles of light only travel in 3 dimensions of space and one in time. So you'd have to have some other way to access these dimensions. And then the immediate observations, we don't see any of these dimensions. So there must be either way too big for us to see. We're just these tiny little ants on the surface of a donut, and we don't know that the donut is curving in this direction or that direction. Or it's the opposite. We're these enormous macroscopic creatures, and actually the space-time is curved on these phenomenally infinitesimally small dimensions of 10 to the minus 30th centimeters that we can also not access. We can't detect them. There's no properties of particle accelerators. There's no microscope that can zoom in, as you say, to see them.
Real quick, to all my Discord people out there, the Julian Dorey Discord is officially live. I put the link down in the description below. So go hit that, join the community, and say what's up. There's all kinds of features in there, and I look forward to hearing from you guys. Let's get it popping.
Now, what Witten did is he realized that there was a way to reduce that number from 26 to 11, and then it was reduced to 10 dimensions.
How?
So this is truly beyond even my mathematical, concepts. But effectively, as I understand it, the compactification was a recognition that the instantiation of these particles, the properties of particles or the properties of these strings, they didn't need to have at that many dimensions, the original number of dimensions. And so this was basically what won him the Fields Medal. There's no Nobel Prize in mathematics. The closest thing is called the Fields Medal, and it's awarded to people under 40 for the greatest contribution to mathematics. And he won it for physics, basically, for these kind of laws and understanding how you could reduce the dimensionality down to a more tractable number. I always say, like, over the summer there was this big brouhaha with that Joe Rogan and Elon Musk got all involved with, which is that this new study confirms or says the universe is 26 billion years old.
Oh yeah.
And I talked about this with Joe on his show, and it's really one guy who I know, he's a nice guy in Canada, and he came out with some model that seems to suggest that, in certain circumstances, you could have a universe that's older. It would be needed to be older in order to explain the properties of galaxies that are much, much younger or too young in a universe that's only 13 billion years old.
And for people following out there, we basically go up the scale: solar system, galaxy, universe. So he's looking at the whole shebang.
Clusters of galaxies between that and then the universe. Yes. So he was looking at, really, as you look back in space, you're looking back in time. So light, the only good thing about using imperial units of feet and so forth is that light travels 1 foot every nanosecond. So I'm seeing you're 3 feet away. I'm seeing you not as you are instantaneously right now. I'm seeing you 3 nanoseconds ago. You look very young and very vital and very healthy, but it's not instantaneous. So as you look back to the curtains behind you, those are 6 feet away. So it's 6 nanoseconds. You keep going, go past New Jersey, Manhattan, go all the way back to the center of the Milky Way, go beyond the Milky Way, go to the local supercluster. Eventually, you're going to get back to where there's nothing in your way. no buildings, no planets, no asteroids, no galaxies. And there you're seeing back to when the earliest galaxies themselves are being formed, if they exist. And what this Rajendra Gupta at University of Ottawa said was, well, based on my calculations, one person's calculations, bolstered by, he didn't make any errors or blunders, but he sort of came to the conclusion that the universe had to be much older. We'll talk about that later because that is a proper controversy that we can discuss. There are others that say the universe is infinitely old. So even though it's twice the age of the accepted universe that Gupta has come up with, it's still a hell of a lot, younger than an infinitely old universe that this other guy, Eric Lerner, had come up with about a year before that.
I just don't know how you can, and this is the total non-scientist take, sitting on the sidelines, just looking at this from the broadest lens you can. I don't know how you can possibly date something that we haven't reached the limits of our solar system, let alone the galaxy, right? And there's obviously things that can go into how physics works to say that we have things like galaxies, and there are collections of galaxies that form the collection of galaxies in the universe. But to talk about the entire thing, which could be infinite numerical values away from us, and to put a finite age on it, that does not process for me.
Yeah, well, I can't. I just want to correct you with my trademark love and affection. It can't be infinite if the universe is not infinitely old.
Yes.
Okay.
Sorry.
But there are people, not necessarily the highest respected scientists out there, even working as professional researchers, just kind of pundits almost, that do say the universe is infinitely old and is static and has never changed. There is abundant evidence that the universe is not infinitely old and infinitely static and infinitely unchanging. But to give them their due, they're in good company. I mean, Einstein believed until 1929 that the universe was static, effectively static. And in fact, he injected into his famous equations a term that would counteract the gravitational collapse that he knew as a brilliant man would be inevitable for a universe that only has matter. So as I told you before, protons repel each other. A proton and an electron attract each other because they're opposite charges. There's no such thing as negative gravitational charge. In other words, gravity is only attractive. In our solar system, there's no gravitational repulsion. There's no antimatter that causes anti-gravity.
Right, it doesn't push you. Yeah.
Right. So Einstein then realized, well, I'm pretty smart. I know we live in a galaxy. The galaxy is made of stars and gas and dust and planets. That's matter. That's only attractive. How come it's not collapsing in on itself? How come I'm here to ask the question of why is there a galaxy at all? So he injected into his equations of what's called general relativity, which corrected the flaws in Newton's gravity, in the same process of going from flat Earth to spherical Earth to pear-shaped Earth, etc. That process is one of refinement. You start off with an idea, you look for the flaws in it, then you look to find evidence and an explanation for why those flaws exist and how to correct them to make a better approximation, a more accurate approximation, and hopefully one that's more precise. So what Einstein did is he said, I'm going to inject this fluid that fills the universe called the cosmological constant or the vacuum energy. And that's going to act like the pressure inside of a balloon that keeps the universe expanded out against gravitational collapse of all the ordinary matter in the universe. And so he did that, later recanted it when he saw from Hubble that every single galaxy Hubble could see was moving away from the Milky Way galaxy. So at first, the very first thing he could say was, the universe is not static, right? Do you agree that in a universe where things are moving, that the universe is not static? Is that, I'm asking you.
Yeah.
Yeah, right. So that torpedoed a scientific idea that held sway for 2,000 years.
Can I go back for 1 second just to make sure I didn't mix that up at the end? But when you were saying static, because there was a lot in there.
Yeah.
When you were saying static, he's referring to it didn't have necessarily beginning. It just always was.
All I'm saying is static means that it's unchanging. It means that the only 5 things they knew that moved are the planets. They didn't know about the other things that were moving in the universe up until, Galileo and used the telescope.
But you had said that Einstein, before he changed his opinion on this, had thought, there wasn't like a beginning that had a creator.
He certainly didn't think that.
And then
he didn't even think that there was something moving or expanding or collapsing. Remember, when you have gravity, and you have this mysterious other force that could blow up the universe or cause it to contract slower or ultimately contract on itself. He wasn't thinking at all about the origin of the universe. That wasn't what was leading him. He was looking at the evidence, and the evidence showed that there are all these nebula, which they thought were outside or perhaps even inside the Milky Way galaxy. And the Milky Way galaxy wasn't collapsing in on itself. So forget about these other galaxies for a second, although they're the crucial key insight that Hubble provided to Einstein to reject his original idea. But looking at just the Milky Way galaxy, there are stars in the Milky Way galaxy, over 100 billion stars. They are not all collapsing together, even to the black hole at the middle of the Milky Way galaxy. What's causing them not to do that? Well, Einstein thought the universe was the Milky Way galaxy, and he said there must be some force, some pressure that's keeping them perfectly balanced, which is very weird, right? Now, it turns out, Julian, let's blow your mind. It is true that there is a fluid that does keep the universe inflated against collapse on itself, but it's doing too much inflation. It's actually causing the universe to expand exponentially faster over time. So tomorrow's expansion rate, the galaxy that's at a certain distance away from us, is going to be farther tomorrow, and it's going to be accelerating away from us at a greater rate than it is today. But Einstein didn't know that back then. So, to be honest with you, I've committed the ultimate, podcaster, cardinal sin. So I don't remember what got us on the subject, but just to say that in gravity with these unification, going back to string theory, perhaps.
That's what we were doing. We were doing string theory.
The ultimate goal would be to explain, why is the universe expanding like this? Why are the ultimate building blocks of nature, the very smallest things in nature that we know about, why are they responsible for the large-scale behavior of the universe? And you mentioned, I think, which did get me on this tangent, it's incomprehensible. How do we even know the universe? We haven't only gone to we've only sent people to the moon. Like, how can we say something about a galaxy that's 100 billion light years away? Or less than that. But the point is that in science, you have to do the following. You have to have some idea of the current best guess for the composition and dynamics of the universe. And then you have to ask a question. What is it about the universe that I can predict will happen tomorrow based on the evidence today? And then using that same inductive framework, yesterday, if I was a scientist yesterday, knowing what I knew only yesterday and not today, what would I have predicted about the universe today? And then you keep iterating that process backwards to the past, into the future, and you ask, do I reach a terminus? Do I reach a point in which there is no way to go back further in time to the past or to the future?
Which would point to creation.
A Big Bang, or an origin of time, or a collapse of a previous universe into the raw constituents of our current universe. And all these models have had ideas from antiquity to today. I mean, I was reading about an Egyptian cosmology from the year 1000 BCE. That's basically a cyclical universe that comes in and out of existence. And, and there are models that have been static, Aristotle to Newton to Einstein believed the universe was static, unchanging. And then the question is, given the evidence that you have today, can you falsify any of those narratives? Yes, we can falsify many, many hundreds of thousands of cosmogonies, origins, genesises of the universe, models for it. And what's left is a small handful. But we can't do that with string theory. We can't really say, well, based on the evidence, this is incompatible with string theory and it's compatible with geometric unity. So that when I do what I do, my job is to, again, not prove these brilliant men and women right. It's to hopefully falsify as many of them as possible. So I ask Eric all the time. He comes and visits. He gives lectures. I go see him. Stephen Wolfram and I talk frequently. We're going to talk again soon.
I'd love to talk with that guy.
He's a brilliant guy. Yeah, he's up in Massachusetts. We'll see. He's kind of a night owl, so it might be like midnight on a Tuesday.
Love it. We'll get some liquor flowing, do the whole deal.
So my job is to always hector these people and say to them, what is it that I can turn my $100 million plus $100 million plus Simons Observatory on? What can you sick the dogs of experimental physics on to get out the falsification, the disproof of what you're saying? Because they're good scientists. So they'll say, well, I predict that there's, so Eric's theory has some unique predictions. One is that it has 2 dimensions of time. Not just one dimension.
How does that work? So
this is a reason, for you to chat with him at some point. But the manifestation of 2 dimensions in time allows for is an additional dimension in the same way that Witten's 10 dimensions are additional dimensions of space. So you should no more ask why 2 dimensions of time than why are there only 3 dimensions of space? So why aren't there? Why can't you move back? Why aren't there 2 dimensions of time right now? In other words, why is it possible that there couldn't be so-called what are called closed loops that you would, in certain trajectories, you could make an excursion in time. And there were people that believed this about the standard model, way before Eric, that proposed multidimensional time. He's not the first person to propose it. And that time property has to have different behaviors, the second dimension of time, that then dovetail with the ordinary behavior of our current arrow of time.
And that would imply also, and am I incorrect in saying that would imply you could manipulate the motion of time?
I'm not sure exactly how. It would be, certainly that you could perhaps make excursions. I say you could take paths, and there are trajectories that a person or an entity or particle could have. Again, we're not talking about people. These could be very compactified as well. So then the question is, well, how could you verify or validate that? How could you validate that there's only 3 dimensions of space? How can you validate that gravity travels at the same speed as ordinary time or ordinary light does? And so these are questions that I ask them, and only in certain theories will you get an answer. And it turns out Eric's theory makes other predictions that are a little bit more testable than these compactified dimensions. The particle inventory of how many particles there are in the universe is a measurable quantity. In other words, we don't know all the particles that could possibly exist.
So how's it measurable if we don't know?
Because they have other properties in addition to like their names or whatever we call them. For example, they have intrinsic properties called spin, mass, and charge.
But couldn't there be particles far beyond what we can visibly understand that we wouldn't even know how they would exist because we don't understand how that would work?
Well, at a certain level, you could always say that because you could say, but I could also say, couldn't there be God or couldn't there be a poltergeist or couldn't there, couldn't there be?
Absolutely.
But then the question is, well, how come, and I always ask it, like, how come these poltergeists and near-death experiences and so, how come they don't manifest themselves with an interaction with the ordinary world, or they only do for certain people, right? So these particles, let's call it a poltergeist particle in Eric's theory, right? So this poltergeist particle does have an interaction in his theory, or will have a manifestation, even though it may not exist to this day. It may have decayed away, it may no longer exist, but because his theory makes definitive predictions about the inventory of these particles, which again, every particle is fungible, right? Like one electron is as good as any other electron. If it has the same properties, it has a spin, an angular momentum, a charge, and a mass. You can swap one out for the other. If I swapped every electron in your body out with another electron, or here's another symmetry. If I swapped every proton, neutron, and electron in your body out with its antimatter equivalent, I wouldn't exist because you'd annihilate everything in this room, but you could exist. There could be completely antimatter versions of this. We've even seen that gravity affects antimatter identical to the way it affects ordinary matter. And some models of string theory or other models, other alternative unification ideas, do not feature that. So every time you do a test, it can be used to exclude the properties of a hypothesized new force, interaction, or particle. And that's where it's valuable to be the, Roosevelt's man in the arena that's actually making predictions. And that's why I get so flummoxed and frustrated and upset when you hear theorists who are a lot closer to it than Brian Keating is. They say, I don't have time to look at your theory.
Yes.
What else are you doing? It's been 50 years. As you said, string theory's been around for 50 years. There are people making refinements upon refinements upon refinements of it. Why not spend some of your time dedicated to either what particle physicists could do, what experimental cosmologists could do? And if you say there's no way to test this, then that's a you problem, right? It's not up to me to think about ways that I could be able to test geometric unity. And it happens to be that as I said, he makes certain predictions. With colleagues, there are ways to bridge the gap between the phenomena that he's proposing with the experimental observables that my team and I can observe, and then test those and hopefully rule out as much as possible. But again, never with the goal of proving.
Yeah, there's a lot of ego that goes into anything where there's high intelligence. It's just the nature of the beast. You look throughout human history, it's never been different. But I did ask Michio about that when he was in here. Do you believe in God?
Well, I believe in the God of Einstein. He believed in God, but not the God that intervenes in human affairs. It was the God of order, the God of simplicity and elegance. Einstein once asked the question, did the universe have a choice? Is it unique? So universes, you can create universes in an afternoon, but most of them are unstable. Most of them fall apart. Most of them don't work. Our universe is stable. It works. Everything fits together. And then the question is, what set off the bang? That's what we do for a living. We have the Big Bang Theory up to the point where the universe is going to explode. Why did it explode? We think it was a quantum event, and we are here because we are in the universe which decided to explode. So Einstein said, was it all an accident? And he thought, no, it could not have been an accident.
Towards the end, I asked him something along the lines of, would you be upset if all your work in your life was proven wrong, or would you be happy to know that that's kind of the whole point of it in the first place? And I don't want to say what he said because I'll get it wrong, but his answer was very, very well thought. It wasn't as much like, no, look, I want to be right about this, or I want to be mostly right about it, and if I'm not, it all goes away. And to me, when you look across a lot of science, and you could talk about this with the disagreement he may have with Weinstein in this case, where maybe he's not looking at it or something like that. But when you look across science, there's so much tied to, if you are told you're wrong, that means that you provided no value. In my opinion, though, we can study these guys from history. We can study the Einsteins and the concepts that they came up with. And if it's all proven wrong, but that incorrectness actually unlocked a layer for us to look at to be able to get a step farther, then to me, that makes their work beautiful.
Yeah.
That makes it the whole point of like the definition of the word itself.
And also say like wrong or right, you're acting, and I'm not saying you, I'm just saying one is
Right.
acting as if science is what's called a finite game. So I don't know, Carol Dweck has this notion of infinite and finite games. I think it's her. It might be somebody else. But anyway, she has the growth mindset versus the fixed mindset.
Carol Dweck, you said?
Carol Dweck. But it's actually, look up Infinite Game. Simon Sinek wrote a book about it, but he's not the one who identified it first. So there's a concept called the infinite game. It's something where there are clear players, clear rules, a beginning, a middle, and an end, and a winner and a loser. Chess is paradigmatic of this, okay? So when you have a finite game, there's a winner and a loser. When you have an infinite game, the object of an infinite game is to keep playing. And the infinite game is very much akin to science. Science cannot be won, but the paradoxical thing is that science is comprised of innumerable finite games. Let me mention one. Undergraduate getting into college. Like you got into some undergraduate college, that means someone else didn't, right? Then you get into graduate school. Then you do what's called a postdoc. Then you might be another postdoc. Then you might be an assistant professor. Then you have to get tenure. Not everyone. So all these hurdles, all these, I call it the academic Hunger Games, because you're like fighting against these people in tribute to, basically your own career of what you want to do in science.
Yes.
And then getting grants is even harder. And then getting publications, right?
So winner and a loser.
But at all these levels, and yet what's the ultimate game that you're playing? You're playing an infinite game. You can't win science. There's no such thing. So when somebody says, well, I hope that I'm right or I hope that I'm wrong, they are treating science as if it's a finite game. And I think that's fundamentally misconstrued. So I don't remember what Michio said, but it's natural. Let's be frank. It's not, if I said to you, oh, it's great, if I get falsified, and I'm proven wrong or I'm in a blunder or I did something dumb, like, oh, it's great, I'll write another book. No. Obviously, as a human being, and you often hear this about projects like the Large Hadron Collider or building another version, a super hadron collider around the circumference of the moon. You hear these things that there could be future things that cost trillions of dollars, right? And it's probably not likely to happen. And some people say, oh, the most interesting thing would be if we don't see what we expected. If we never saw the Higgs boson at the Large Hadron, that would have been so exciting. I'm like, no, it wouldn't be. It would be 20, 30 billion euros wasted, and thousands of hours in people's lives. I mean, you're dealing with people's lives. And I think that's part of the problem that Eric has with people like Witten and even the ideology of Kaku or what have you, that they seem monomaniacally focused on one thing being right and everything else being wrong. And they don't explore, as far as I'm aware. I haven't yet to see a paper by say Ed Witten, where he's looking and trying to explore the intricacies of a rival theory called, not Eric's theory, but let's call it loop quantum gravity. Carlo Rovelli and Lee Smolin, brilliant people that promulgated this for Abba Ashtekar. Brilliant minds. I haven't seen like a debate between those two. I think people want to see Eric, fight it out with Michio. Although I wasn't clear from the interview if Michio had any idea who Eric was.
So the full story there is actually a little bit funny.
Yeah.
So I'm not a gotcha guy.
I know. Yeah.
Right? I don't do the whole you're walking into a buzzsaw here and I'm going to hit
sure?
you. No, not at all. Not at all. That's not my job. You want to go to like CBS or ABC or Fox News or CNN, go do that. But when he came in and we were setting up the studio and everything, I didn't really think about it. I just casually asked him, "Oh, did you see?" Because it was kind of funny. Like,
Right.
let's be honest.
Yeah.
Like Eric Weinstein is
Michio Kaku
he
is out of control.
He is
he's,
involuntarily funny as fuck.
I think he knows what he's doing.
And so the way he said it, he's just sitting there, and sometimes I feel like he's having especially when he's on with Joe, like he's just having a conversation with himself, and Joe's just like, okay, like I don't know, but he's sitting there, and out of nowhere, he's like, Michio Kaku, get Michio Kaku in here with me. Michio Kaku's out of control, and he's like staring at Joe, and Joe's like, why? He's like, he's doing this, he's doing that, and so I said to Michio, I said, what did you think of that? Do you think there's valid criticism or whatever? And he looks me dead in the eyes, and he goes, who said this? And I go, Eric Weinstein. He was talking about this on Joe Rogan. You've been on Joe Rogan before, right? And he goes, yes, but who is this person? And I'm like, Eric Weinstein, the mathematician.
Do you think he was like belittling Eric?
Not at all.
Anyway?
I want to be. I want to be so.
He just has no idea.
I want to be so clear.
But isn't that a problem, Julian? Isn't that a problem that you don't know who your chief? I'm not saying you have to respond to every troll or whatever, or do everything, but that you don't know who they are necessarily, and that bespeaks again.
He asked for it though. To be clear, like he said, I don't know who this is.
Right.
And he was like, Can you show me this?
Right. And then he said, "Oh, if you can't stand the heat, let's get in the
it.
kitchen." And then I replied, "Well, I'm happy to provide the utensils and the Gordon Ramsay like experience as your impartial host." And I've had both of them on. Obviously, I've been on Michio's podcast. I've been on Eric's, although he never published it.
All right, sorry about that. We should be good now. But we were talking about how Kaku didn't know about what some of the critics were saying, and I'm sorry if your point got cut off there, but yeah, I do want to be clear. There was zero like, oh, who the fuck is that? There was none of that. He asked to locut at it, and then he was like, it was hilarious watching him like turn to the TV and like intently watch, and my friend's looking at me going like this behind, like, cut, like this is too much. But he watched it for like 90 seconds, and he's like, "Well, I'd have to look at the theory." But he's like, "If you can't take heat, don't come in kitchen."
That's
I was like, "Oh my god!"
When
Fucking hilarious.
When he was when I think when he was saying that, it did seem like, well, maybe he'd be open to it, maybe he wouldn't. But look at it. There's a famous quote, I think, from Richard Dawkins. And you say, "There's somebody who wants to debate you, Professor Keating or Professor Dawkins. You're wrong about evolution." He goes, "I can see how that would look really good on your CV." Yeah. I can see how it looked really bad on my CV, right? Yeah. So there's this sort of risk aversion for people, that have gotten to the level of a Witten, Fields medalist. Is he going to talk to Brian Keating? I mean, he's turned down my many requests to talk, right?
Witten has?
Yeah.
But he doesn't really talk on stuff, right?
No, I mean, he'll go on.
He'll talk with that one guy. I forget his name.
Yeah, he's talked with Graham Farmelo, who's a friend I've had him on. And that's fine. He's moved away. I mean, he's been getting into more esoteric, actually related to astrophysics rather than, string theory and stuff like that in recent years. But again, if you look at their publication records and you say, well, like, what are these theorists doing? How many papers are they putting out? How many students are they advising? How many conferences are they going to speak at? Do they truly not have time to look at? I mean, there's only like 2 or 3 theories that have come up that are, plausible challengers. And I've had them on, and I also hold them to account. Carlo Rovelli, look, this result from, these quasars at a distance of, 1 billion light years, they seem to be inconsistent with the discretization of loop quantum gravity. What do you have to say about that? Oh, that's a good idea, But like, I'm sure that he knows. I'm sure Carlo and Eric and Garrett Lisi and Stephen Wolfram are more than familiar with string theory. And the question I always have is, why isn't the converse true? Why don't these other people have an understanding or the limitations of just some of the basics? And Eric points these out all the time. Why are there, 3 generations of fermions? Why are there, the no spin 3/2 particles? And so there are lacunae, flaws in string theory. Everybody knows
There's
that.
what flaws?
Lacunae or gaps. There are gaps in the education.
All these science terms, man. You're trying to throw them right above me. I'm from Jersey. You gotta go slower.
Okay, well, you know what they call the Holland Tunnel, right? $20 is a cheap price to go out of New Jersey. I kid because I love. The origin of the universe was discovered here in New Jersey,
this is where
right?
Edison was.
That's
although
right.
He might have stole some tech.
Was Tesla here?
Tesla was here. Yeah. That's the guy he might have stole from.
Yeah, he could be, right?
We got both of them.
So they were rivals, right?
Yeah,
so
we're
you see
good.
this. You see
Don't
these
worry
ego.
about it.
Now that's in the thing where there's not only intellectual stakes and bounties, right? There's tremendous financial bounties, right? And as well as ego and so forth. So when you look at the landscape of it, I always want to just ask, here's a rubric, here's a checklist. If I'm talking to my students, I ask them, here's what you have to do to get an A. Like you have to do a certain amount of homework, you have to participate in class, you have to do discussion sections if you want to get extra, so there's a whole list of things that they have to do. For string theory, what would it have to do? What phenomena would it have to explain? And the beauty is that all these things have the same job. They all are trying to explain the fundamental linkage of gravity with the other forces of nature. But again, you don't see these people. So let's say that they can't attest to string theory. There's no way that you can prove or disprove string theory other than getting 30 orders magnitude, range in the mass of the electron, say, as Cameron Buffett told me. Let's say you can't do that. Why aren't the same people working on a grand unified theory, which you can test? You could test it with the Large Hadron Collider. In other words, there are ways to test.
How would that work?
Well, there are certain, how deep do you want to get into like how particle colliders work and so forth? So
you can.
Okay, so if I show you collisions between a bowling ball and a crystal ball, right? You can learn things about the properties of the materials that each one is made of by how they behave when they interacted with each other, depending on the speed. So you shoot them together at 1 inch per hour, nothing's going to happen. You shoot them at 1 kilometer per second, something is going to happen when that occurs, right? So depending on, and then you learn, well, the strength of the materials, one is stronger than the other, one is more massive than the other. You learn about the shrapnel that tells you about the materials properties, the chemistry, right? It's the analog here with particles. Particles don't have chemistry. They're particle physics, right? So you learn about the interactions. Are they interacting at the level of 10 to the minus 10th centimeters? How strong is the interaction between these particles? What is their cross section? Are there other particles participating, adding to the dynamics of the collision? The shrapnel that comes out from them, all those things you can learn from particle accelerators. And again, what we're trying to do in the grand unified theory, test your knowledge, right, is not unify with gravity, which could require the entire universe to test, right? They're testing the properties of particles, the unification of electricity and magnetism, the weak nuclear force and the strong nuclear force. To my mind, that's an unsolved problem. It's right there for the picking, but guess what? You don't get maybe the same glory as, you don't get to be put in the same book that has the God equation as its title, as Einstein and Kaku and Witten. And
it is marketed very well, like the what they're trying to get at, to leave off with Einstein's work that was left on his desk. The marketing of we're looking for reading the mind of God. How do you beat that?
Right. Yeah. And it's much more quotable to say that than I'm looking for the reaction cross section in Barnes between a muon and a positron. You just don't get the attention for doing that.
Well, the big problem here, as we laid out earlier on in this podcast, is that we're still at a point here in late 2023 where it's not testable to do string theory. And I feel like, looking at it from the outside, part of that holding on to it and putting an emphasis on string theory having the most potential to be correct is the fact that there is this multi-generational wait to see when we can test it. So do you think it's possible that if we get to like quantum computing or something like that, we will be able to test particles that small that would be a part of string theory?
I actually don't know if it requires new technology. It may, in the sense that when we start to look at the earliest moments of the universe, the best collider that you can get is the one with the most energy. Because when you smash these things together, you're showing not only the constituents, the chemistry of the bowling ball and the crystal ball, right? You're also exploring what freedom do these particles have to move in different directions? And that's part of what these particle accelerators get out. Now, the particle accelerator that the largest one ever built is the Large Hadron Collider. It's about 27 kilometers in circumference. It goes between France and Switzerland. And it's an incredible monument to the technology and the physics of the 21st century. It's where the Higgs boson was discovered, but very little else. There are other experiments there not related to finding new properties about the Higgs. And when I say they found the Higgs, that means that they measured the three properties of a particle, the fungible three, that are the mass and the charge and the spin of a particle. That's really, it's on its license plate. That's what each one of these things has and nothing else. So again, each one is interchangeable. So they discovered what is the charge of the Higgs boson, which was 0. What is the mass of the Higgs boson, which is some number 125 giga electron volts. With accuracy. In other words, there had previously been a maximum limit, like when I said you're 1,000 kilograms, it was like you're 26 kilograms at the upper end and you're 124 kilograms at the lower end.
Very precise.
Very precisely. And it's gotten better and better with time. But that's really it. I mean, these are heroic contributors. I had on Harry Cliff, who's an amazing young scientist. Many people from the Higgs from people that worked on the LHC, rather. Part of it's led from UC San Diego, and where I am, and two different experiments measured exactly the same results. It's a beautiful thing, and these are billions of dollars worth of experiments and tens of thousands of people's career years. So I don't want to dismiss it or cast any aspersions. It's a heroic accomplishment. But to date, that $20 billion project, when you include the construction plus operating it for over a decade, and the upgrades to it has been, tremendously underwhelming, I think, of most physicists, not because they didn't do a good job, just that's all that they were able to access with that level of microscopy, of looking at the finest scale interactions between these things. We don't believe that any collider like our current generation collider can do it. But the biggest collider there could ever be is when the first moments of the universe produced the first particles, energy, forces, and fields. And that's the kind of topics that my colleagues and I are trying to study.
You're getting to the Big Bang with this?
Yeah. So the Big Bang is basically a term that we use for multiple things. One is the formation of the universe, i.e. the beginning of time. One is the earliest epoch in the universe that we can apply known laws of physics to. And that could be, because of limitations in our understanding of physics, or it could be in limitations of what is possible to know. In other words, there may not have been any moment before the Tuesday on which the Big Bang occurred, or what have you. So looking at the universe as a collider, and then looking at the shrapnel that comes off of that collider, namely the artifacts, the fossils that have persisted throughout time, just in the same way that, the Raiders of the Lost Ark, there's a fossil, there's a relic, the Lost Ark. It's traveled through space and time to get to us today. And we can make models about, well, how was it formed? Where did it come from? And what have you? Or a T-Rex skeleton, we can make models of how old it is, how it was formed, maybe how many other such objects exist. The same thing we do with this meteorite that you get on my website, or that I gave to you as a great cost.
4 billion years, baby. Let's go.
So you make models and then you can test them. We can do the same thing. We can ask questions. What is the earliest epoch that we have physical evidence from? What are those pieces of evidence? And what can the archaeology of space-time tell us about not only what those conditions were like back then, but what will happen in the deep future of our universe? And that's kind of uniquely the purview of cosmology. We've never done a particle, we've never detected, I shouldn't say we've never, what are called cosmic rays, particles from the sun or from supernovae, or these are like protons and electrons accelerated near the speed of light. A single particle with the energy of, I was going to say Nolan Ryan, but I don't really, maybe. I'll say
Nolan Ryan could still throw.
Jake Snell.
Okay,
the Padres, right? Okay. Hopefully Cy Young, or I don't know if he won the Cy Young or not. But anyway, a fastball, a single particle with the energy of a fastball from a Major League Baseball pitcher. Okay. These are discovered. They were discovered in space or on balloons on the Earth in the 1920s and 30s. But those are some of the only particle properties that we ever discovered using astronomical technology. But now, almost without disagreement, the future discoveries in particle physics will come from cosmology and astrophysics. The properties, there is a type of particle, there are only 17 so-called elementary particles. That's a particle you can't chop into another particle. A proton can be chopped into quarks, right? We can't chop up the quarks. A neutron also into quarks. An electron, it cannot be chopped into anything. What string theory will say, oh no, it's a manifestation of vibration of a string, right? But we don't know that for sure. But so what we know, there's 17 of them, including the Higgs boson, that can't be destroyed or reduced further. So they're called elements, elementary particles. There are 3 of them. They're called neutrinos. We know that the neutrinos have mass, that they weigh a little bit. Actually, they're the lightest of the known particles. But we don't know what that mass is. With experiments like the Simons Observatory and other astronomical observatories, we can constrain and actually detect the mass of these wispy ghost particles, of which trillions are going through us every day from nuclear reactions from the sun and throughout the cosmos. So we're going to measure for the first time with a telescope the properties of something that used to be measured with a microscope, like a particle accelerator. It'd be as if we're going to learn about DNA from looking through an X-ray telescope. It kind of should blow your mind, right? We're going to learn about the building blocks of nature by looking through a telescope, like the ultimate tiniest things. We're learning about them from the universe as a particle accelerator laboratory, and effectively a grand experiment on which every property of every particle plays out. So it's quite exciting time to be a cosmologist in particular.
It's wild how much innovation we have out there that like guys like me never even think about. And even when you listen to podcasts, you're only touching the surface of what everyone in the world is working on. It's just crazy to me, and I'm sure it's way crazier.
It's actually harder when you're in the field, right?
But do you ever, we touched a little bit on creation in this conversation so far, but not like specifically. Do you ever just get stressed out about not knowing where it all began as a scientist? Everyone thinks about this, to be clear. Obviously it's the meaning of life, but as a scientist where you're trying to find your way there, does it ever just like you're like, holy shit, like it crashes in on you a little bit?
I don't have as many of those, kind of moral quandaries or crises of faith. And I think it's because of something I heard, in the saying something like, a poor person has, basically a rich man has many, many worries, and a poor man only has one, or a sick man only has one wish, right? So I think the crisis of sort of, meaning is a luxury that one will have. And I'm not saying you're some entitled person, but by the byproduct of how amazing it has been for civilization to have relative periods of freedom and peace, where we're at liberty to just do things that are useless, that don't actually create GDP or, directly impact a cure for some disease or something like that. So in my estimation, I'm so busy concerned with the logistics of day-to-day activities of trying to get this student to get his PhD, trying to teach this class of undergraduates, trying to, prepare this paper for publication. And, these things take so much time, trying to get people to a telescope to take data so that we can release it and publish findings, so the funding agencies will keep supporting us and we can keep developing and expanding and making, new inroads and so forth. So as an experimentalist, I don't really have the luxury to sit around and think about, what does it all mean? Now, as a religious person, as somebody who is a practicing Jew and does proceed to think about the ultimate meaning of life on a daily basis, multiple times a day, in fact, then I do question how people don't come up with those moral and existential crises. And I kind of hinted at it before in the context of theoretical, scientists versus experimental scientists, in that, all of what we do is, it may be important, but it may not be significant. Like the average thing that, is it going to really change the world? And I feel that way, by the way, about like celebrities or, people I love, are they important? Yes. Are they significant? Is a Kardashian like changing the future of the world? I don't know. Not maybe to, someone who likes Skims or whatever, right? She's got a lot of good merch. I envy that. But by the same token, if you don't think about the existential questions, then you shouldn't be a scientist. If it never occurs to you that what you're trying to do is unveil the ultimate building blocks of nature that have been hidden for the entirety of human existence up until now, and you have a right to be a part of that, and you don't question it or think about the big picture, I think there's almost it should feel evocative of embarrassment that you're just basically doing a technical trade, which is beautiful. I love technicians. I used to work on old cars. I still do. I love technical things. I don't love plumbing. I'll get somebody to do it, but I'm not denigrating that at all. But those people, their jobs are not to think about the origin of existentialism, and yet your job is, in a certain sense. Now, should that lead to a feeling of panic? I don't necessarily think so. I think it should be it should energize without enervating. It shouldn't be irritated about it. But likewise, I get kind of bemused or just find it a little bit silly when you hear people that will talk about, well, because we're so small in the universe, that actually gives me great comfort because like our lives are basically meaningless compared to the vast expanse of history, the future unknowable domain, and the size of things in the universe that make us basically, this speck of dust, floating in on a sunbeam, right? I think that's grandiose. I think that's false humility. I don't know anyone who acts like that. Like, oh, I'm not going to pay my taxes because what is it? What is life? It's, like Annie Hall when Alvy is as a young man and he won't do his homework and he says, I'm not doing my homework, Mom. And his mom takes him to a therapist. The therapist says, Alvy, why aren't you doing your homework? And he goes, because the whole universe is expanding. And after a billion years, the universe will rip apart and everything. And his mother goes, shut up, you idiot. Brooklyn is not expanding. So it's true. You have to balance that. You have to balance the grandiose with the quotidian, with the daily kind of activities. And to me, my job is this ideal balance between the two. I get to do what I love. I would do it for free. I did do it for free for most of my childhood. Have a telescope, look up, make images, make sketches. Develop ideas and theories for stuff. Learn about the calculus behind the orbits of comets that I was seeing and stuff like that. It really got me into it. Never did I once think it could be a job, that could pay me, and that payment would be, the payment and the additional payment that I believe I receive from my channel and doing outreach to the public who ultimately pay our salaries as professors. And I don't care where you are. You could be at Harvard or you could be at, Cal State, San Marcos or whatever. You still are making a difference because of the largesse of the American taxpayer at a certain level in your education. So to me, to not give back and not explore it. So my podcast is where I scratch that itch of the existentialism, the theoretical, the philosophical. I'm going to speak to a philosopher later today, a philosopher of physics, David Albert, while I'm in Manhattan, Brian Greene. Those are the chances that you get to talk about the real meaningful things, the people that I want to talk to. And then there are people I have to talk to. There are people at, the different government bureaucracies and campus, campus administration. I have to deal. Those are not necessarily people, that I want to talk to. I wouldn't it's funny because my wife's like, oh, well, I love, I'm always like, oh, why don't you just call an Instacart? She's like, no, I like to go to the supermarket. And I'm like, oh yeah. So if our neighbor called you and said like, I'll pay you $5 to go to the supermarket for me, you go and do it. No, of course, you kind of rationalize stuff that you like to do. I know I have to do that. There's committee work. And it's funny because as a professor, I thought as a kid, when I thought about what professors did, I was like, oh, they're just sitting around, they're stroking their beards or they're looking through telescopes all day. And I'm like on telecons, way more than I'm on telescopes. And that's kind of unfortunate, for the young kid version of me. But I luckily get to kind of, embellish and delve into that other side of my character when I get to do podcasts and be on podcasts like this. Very, an honor to be here today. So.
Oh, I'm happy to have you.
Yeah.
It's very fascinating when I get to speak with guys who a part of what they do, as you laid out there, is to think about these things, and I will admit I have the luxury, I guess, of thinking about it sometimes. Yeah. Usually it's late at night when my thoughts aren't so quiet and I'm trying to make them quiet. And then, of course, I start thinking about, well, what is nothing? Why is that? Nothing has to be something in order for nothing to exist.
And then the edibles kick in.
That's it. That's even without the edibles, man. I'm thinking about it sometimes. But, it's the ultimate question we all have. What happens when the lights turn off and when we're not here and what we're doing? And if there were ever a scientific way to prove that, it'd be pretty fucking incredible.
Yeah.
But, to look at your own background and what kind of where you've been. I know you laid out a lot of your childhood and story when you were with Joe Rogan, so I don't want to go through all of it here. Like, people can listen to that. You did a great job with that. But you were adopted into a Catholic family.
Mm-hmm.
You later became Jewish, but somewhere along the way you were atheist, and now
Yeah.
you consider yourself agnostic. And I was thinking about that while you were answering that question, because it seemed to me like you were maybe implying that there was something at the beginning. So for people out there who aren't as familiar with agnosticism, what is that, and what does that mean to you?
Yeah, agnosticism kind of arose as a middle ground, perhaps, between the purely theistic conception, where there are just people that have ultimate faith, and they almost faith transcends into belief, almost at the level of evidence and direct encounter with Jesus or God or whoever. And then they're the atheists, which means not theists. So you're defined by what you're not, which is kind of strange. And then there's this middle ground of folks called agnostics, which means that it's not knowable. Gnosticism is a sect or an ideology that suggests that there are truths that are knowable. What eschatological, what happens in the deep future, end times, or after death. One of my kids was asking me, what happens, what did I look like before I was born? I'm like, what the, where's that children's Flintstones chewable edible? No, I don't do that. But looking at these big picture topics, thinking as a scientist, what is knowable via the scientific method? In other words, when I said before, you can make up whatever theory you want, but if it doesn't interact with the standard model of particle physics, with gravity, with forces and fields and particles that we know about, then it's just literally complete esoteric sophistry and philosophy, right? And that's what some people accuse string theory of. And then there's a counter reaction that no, it'll actually make predictions. We just don't have enough energy to get to them. Okay, let's leave that aside. But if you say something like God, like, does God exist? So a theologically inclined person will say God exists. He intervenes. He's a personal God. Yeah, I'm talking about Judeo-Christian God, and it's the only one I'm familiar with. But he interacts in the physical world. Well, then there should be some physical. You should be able to build a large, Hashem, a large, God collider. You should be able to see. Well, no, but they'll say, well, no. He interacts in other ways and changes laws and so forth. And that's what prayer does. Prayer has an effect, an immaterial effect, right? There's no, cranial functional magnetic resonance imaging helmet I can put on.
Can't measure it.
You can't say that has an effect. You can see that things light up in the brain differently when you do that. It's a well-known fact. And you could even say, what is the influence on people's happiness and their charitability and the way that they live? And those are all functional benefits of being actively theistic. Now, to me, what I call myself is a practicing agnostic, not just an agnostic. So an agnostic will say, I don't know, but practicing means, but I'm searching for evidence. So if you say you don't know, you're an agnostic, or that it's unknowable, there's one of two options for you, right? You can say, I am going to act as if I don't know, which would mean, that's the way a good scientist should approach things, and say, well, let me investigate the two alternatives, right? So I can investigate atheism, which I have done, and I was atheist for many, many years, and I can investigate theism, or practicing a religion, right? So let's say, and I interviewed my first guest ever on the Into the Impossible podcast, was a renowned titan of physics who did truly lose the Nobel Prize, named Freeman Dyson. The Dyson sphere is like the one.
What do you mean he lost the Nobel Prize?
And that he was co-inventor of some of the theory associated with quantum electrodynamics that Richard Feynman did win the Nobel Prize for. But there were two other people who won the Nobel Prize that year, and the Nobel Prize has these stupid rules put into place, not by Alfred Nobel, but by some committee of Swedish scientists back in the early days of the Nobel, that only allowed 3 people to win it.
So wow.
But it's totally arbitrary. There's nothing special about 3.
What they do, eeny, meeny, miny, mo?
They just excluded him. They just gave it to 2 other guys, Feynman and 2 other guys, Schwinger and Tamanga. And they definitely deserved it, but Freeman deserved it as well. Anyway, he never complained about it, and he was a gentleman until he died 2020. But I talked to him on my podcast the first time because he called himself an agnostic. And he had won, there's a prize called the Templeton Prize, which is endowed by John Templeton of, Franklin Templeton Fund and other, to be always worth a little bit more than the Nobel Prize. And it's for showing the consilience or the reconcilability of religion and science. That's why he endowed it. And he made it more prestigious, I hope, by making it worth more money. So Freeman had won it many years ago, like 20 years ago, 30 years ago. And when he was on my podcast, I asked him, well, like, what do you consider yourself? And he's like, I'm an agnostic. And I said, okay, so do you go to church? And he was like, no, I told you I'm an agnostic. And I'm like, well, wait, but you're an agnostic. So if some brilliant alien, is looking as cruising by in my friend Avi Loeb's Oumuamua, right? And the alien's looking down and it sees Richard Dawkins or Lawrence Krauss, upcoming guest on this podcast, past guest on my podcast. And you see Lawrence Krauss, self-declared militant atheist. And Lawrence is not going to church because he never goes to church. He never goes to synagogue, never goes to temple or whatever. And then he sees Freeman Dyson. How could that alien, intelligent as whatever you call it, whatever its pronoun happens, space pronoun is, how could you functionally distinguish between those two people? And he said, you can't. There's no way. Because they're not practicing anything. They're not doing, the agnostic and Freeman was not doing anything. He was just kind of living off the interest that he had accrued as a young man when he did go to church. And he actually, to give him his credit, he would sometimes go to some fellowship, Quakers or what have you. And he was not anti-religious, but he wasn't actively pursuing the search for truth and knowledge.
So did you start referring to yourself as an agnostic when you started practicing Judaism?
That's a good question. I think only in retrospect do I realize that's what I'm doing now. And I should say, practicing to me means like eating kosher food, because so I was born into a Jewish family, parents divorced, as you said, adopted by an Irish Catholic guy, grew up in his family, amazing family, became so enthralled and in love with Catholicism that I became an altar boy, never had a bar mitzvah. In fact, I just had my bar mitzvah in Israel. And thank you. Toda rabah. In Israel in September, and that was an amazing time to be there, as it would be very difficult to do that right now, as you know.
Wow, you were there right before.
I was there a week or two before. Yeah, and we can talk about that later. But so practicing it. So I did these things. I learned to speak Hebrew. I learned to read Hebrew. I wanted to understand this whole legacy that I had been gifted and whether or not there was validity to it. So for the last 20 years or so, since 9/11, actually, 9/11 was the inciting incident that made me want to investigate the religion of my birth and get closer and more connected to it, including, raising a family and so forth. So that's how I practice it. I learn every day. I read the Bible, the Old Testament in my case. I study the ancient philosophers. I engage in weekly study with rabbis and friends. I keep the Sabbath. I don't work. I go to a temple. And so these are very important things to me. But I can't say ultimately that I believe in God. It's a very strange thing. Like, I don't say I believe in gravity. I never say that. I don't believe in gravity. I have evidence for gravity. Yes. And so it's something it really tells me that I have two sort of fathers in a sense. One is like Galileo, empirical scientist, the first to come up with the scientific method to discover that laws of mathematics could be verifying physical phenomena in space. And he's sort of my scientific, father in a sense. And then I have my, religious father, so to speak, and the people of my ancestry and so forth and philosophy. But ultimately to say that I believe in God is a very strange thing for a scientist. So those two forces are at war within me. Can I reconcile the two of them? No. Can I solve? Can I prove? No. But part of life, again, religion, like I said about science, is an infinite game. You can't say, I want it. And when you meet with Lawrence, you can ask him the same thing. When did you stop learning about Judaism, the religion of his birth? And he'll say when he was 13 years old after he had his bar mitzvah at the typical age, not as a 50-year-old guy. And he hasn't studied it since, and he has a very superficial understanding. And I've done studies with him, and he will dismiss it, and he'll say it's this band of Bronze Age peasants, and what did they know about this and that? But I'll always point out that there are life truths that he actually adheres to, and owe their heritage, as does much of Western civilization, to the Old Testament and our series of laws and so. So there's obviously wisdom and value to it. And the question is, why would you abandon a source of wisdom? Like, I don't read A Brief History of Time.
Okay.
No, I don't read A Brief History of Time to know how to raise my daughter. I read A Brief History of Time to learn about a theory of physics that's mostly now out of favor, that was written in the 1980s, right? And that's interesting. But as you asked about like Kaku before, I would have hoped, and we go back and look at your interview with him, but when you asked him, do you hope you're right or hope you're wrong? I hope that all my theories are wrong, or my ideas or my discoveries are wrong, in the same sense as the Earth being a sphere is wrong. In other words, I hope that they get refined. I hope that the ultimate truth that we can get closer and closer to, but never exactly arrive at, is achieved after the science improves. Otherwise, what's science for?
Well, the other really important thing about every opinion you're expressing on the topic of whether scientists are right or wrong and how they should feel about it is that you have personal experience with that and are not only open about it, you write about it in your books because you were working on Bicep and you thought, I'm not going to get into the full terminology, I will let you do that, but you thought you were looking for one thing. It turned out you were essentially looking at dust, but you had this highly complex, potentially groundbreaking idea that could show us what the beginning of the cosmos might look like, and then you spent all the time on it to figure out we don't know that. And I don't think there's anything wrong with that, but in your field, it can be that scarlet letter of, oh, his entire work was proven wrong. And so when you are going through all these things and all these scientists who are afraid to even explore the topic of, well, maybe we're looking at this the wrong way, you've been there, done that. I respect that a lot about you.
Yeah, to me, it's a natural way. It's not necessarily commendable or condemnable, but to be open to being wrong if you're not a scientist. And the type of flaw or issue that we had with Bicep and that I describe in Losing.
And can you explain it if you don't mind?
Yeah. So what we were looking for again dates back to this distinction of the universe as the ultimate particle accelerator, as the ultimate atom smasher, particle collider, however you like to phrase it. When the early universe began to produce out of nothing, perhaps, according to Lawrence Krauss, a universe from nothing, a fluctuation in a quantum foam that pre-existed our current universe and what's called the multiverse, perhaps, or the collapse of a previous universe onto itself that ignites an explosive origin event that then became the universe that we know and love today. That event, whenever it was, may have been accompanied by a new type of force field called inflation. So totally different, only existed for a vanishingly small amount of time, for actually a trillionth of a trillionth of a trillionth of a second, 10 to the minus 36 seconds. This phenomenon called inflation took place where the universe expanded from atom size to the size of the size of a school bus.
That's based on time as we know it in this dimension, though, right?
It would be elapsed time, as we say it. In other words, if you had a stopwatch that could measure trillionths of seconds, you'd see a trillionth of a trillionth of a trillionth of a second go by. Yeah, so absolutely the correct way to think about it. So the universe expanded from less than the size of a kind of atomic size or molecule size to the size of a school bus in so faster than the speed of light, and that conjecture then, if true, explains a host of other cosmic phenomena, including the structure of galaxies that we see in the universe, the clusters of galaxies that we see in the universe, and many other phenomena. It's called inflation. It's sort of the spark. If you think about the Big Bang as an explosion, it's not really an explosion of any kind like a firecracker, but if you want to think about it, fine. It would be the match that lit it off, and that match was only ignited for a trillionth of a trillionth of a trillionth of a second. Okay, so that event then cast the die for what our universe would look like. So by looking at the universe today, we can infer what properties it would have had in the past. Just like we can infer that from the way you look, that you were once an egg and a sperm. We don't know exactly which egg and which sperm. I'm going to keep it PG here. I know you're classy, right? It's
a very R-rated podcast, so you're okay.
Okay,
go as deep as you want.
So you can even nucleate. When that first single cell became two different cells and started to split and start to divide. It's called a blastocyst. It's a collection of cells. We can infer what that looked like, even though we don't know what you would look like. So in other words, we're looking at you today, and I'm trying to predict what was that blastocyst, that 100-cell clump that you were 100 seconds after your parents' Big Bang, whatever, 30 years ago.
The right thing.
Exactly. So when that happened, we can make inferences about that. In the same way, we can observe the shrapnel from the universe, the properties of the universe today, and infer what was it like at this early epoch. But we've only been able to go back to about 380,000 years after the Big Bang to this time using light. Light is produced in the form of the cosmic microwave background discovered here in New Jersey, down the road in Holmdel.
Jersey?
Oh, sorry.
That's a good one.
Yeah. So I'm going to get all these people thinking I'm a white nationalist. But anyway, they'll have to read my autobiography to know about it. I'm not. But anyway, looking back at the heat that's left over, that's as far back as you can go with light. But if there's a irate, cabbie driving across the street here, we can't see him, but we could hear another form of radiation, i.e. sound, right? If he honks the horn, F you, or whatever, right? Or, go Giants. You could hear it. So other forms of radiation can tell you about things that are not only of a different type of phenomena, but actually are farther away. And remember I said when something's farther away, it's older in time. You're seeing it as it was young. So we're using, instead of waves of sound, a type of vibration called the gravitational wave. So if inflation took place, which we don't know, we're trying to substantiate, find evidence for, but we're not trying to prove it. Remember, that's not our goal. We're not trying to prove it. We're trying to falsify everything else. All other competing theories do not have these waves of gravity. Only inflation does. So therefore, if we see inflation, we don't prove, if we see gravitational waves in a background, they emanated from this trillionth of a trillionth of a trillionth of a second after the origin of our observable universe, potentially from a multiverse, or a larger expanse of space-time. And that falsifies all these other models: static universe, bouncing model, cyclical cosmology, string gas cosmology. All these, there are many, many models that don't feature this type of behavior. It'd instantly be proven wrong. We thought we did that on March 17, 2014. We announced that we had done that with the previous experiment, a successor to an experiment I invented called BICEP. This one was called BICEP 2, very creatively. It was announced at Harvard. Avi Loeb was part of the announcement.
Where were you doing this?
So this experiment was done at the South Pole, Antarctica. It was a telescope, just like Galileo made a refracting telescope and used it to learn about the origins of his own universe.
So for all the flat earthers, you walked off the edge.
That's right. I went to the bottom, and I saw with my own eyes. Actually, if you're there, it looks totally flat. It's pretty funny. The South Pole looks just like the most flat, boring. Even worse than the central pine barrens here. But anyway, looking at the early universe from this vantage point, we claim we saw these waves of gravity, their imprint on what's called the cosmic microwave background, and yet we knew there were other imposter signals. No scientist nowadays.
What do you mean by imposter signal?
A signal that could produce the exact same effect, mimicking inflationary gravitational waves, but not produced by gravitational waves. It would be like you look through a telescope, and your theory is that the moon has this swirling fingerprint on it. There's a pattern of craters and valleys and volcanoes on the moon's surface, okay? And your theory is that there are canals on the moon, and they're made by a god, and the god left his fingerprint on the moon, okay? So you're looking through your telescope. I saw evidence for that. Holy crap, I'm going to be super fun. I'm going to win the Nobel Prize. Then you look at the telescope. Oh, shoot. I put my thumb on the lens, okay? So we saw something that exactly mimicked the signal that we were looking for, which was inflation, this swirling, twisting pattern of microwaves called B-mode polarization. I describe in the book in great detail. And that pattern was produced not by the waves of gravity, just like in this analogy, not by canals on the moon or swirling pattern by a god. No, it was produced by tiny little micrometeorites. Pass me that micrometeorite I gave you so generously.
Billy right here.
This Billy boy. So if you put this in space, remember I said this is what is this made of? Pop quiz. What's most of it? What's in your blood?
Iron.
Yeah. So iron is the predominant, makes up the predominant composition of this meteorite. A little nickel, cobalt, and some other elements. Okay?
What number on the table is that?
Well, say that again?
Iron
is 27. You got a computer here. So I think it's...
You're the scientist.
27.
All right, we'll
Scientists don't memorize all these things, right? I leave that to my assistant Bard.
They said you got to memorize all this shit?
I would not advise that at all. I'm guessing it's 27 or so.
element periodic table.
Yeah, let's see
Let's
it.
see what we got here.
Let's see it, baby.
Dun, dun. 26. You were one off.
Wow,
Tough.
how's that?
Tough.
Dang it.
Anyway.
So when this is in space, this, or if it's in your refrigerator, or if you win one from BrianKeating.com, you put a refrigerator magnet on it, it will stick to it because it's magnetic. Iron is highly, it's compass needles and can be made of it. So it gets aligned by magnetic fields, just like the needle of a compass. So this is like an odd shape for a magnetic needle for a compass, but it actually can act like a magnetic compass. Imagine this shrunk down or shaved off. If I were cheaper, I would have brought you like a little tiny shaving of it, like a little filing, a little tiny particle of it. Well, there's a lot of those. You ever heard of a power law? Power law is something that there's a lot of things that are small, and there's very few things like companies. There are a lot of small companies, pizza restaurants, gift shops or whatever, and there's very few like Apples, and Googles.
You're talking like 0 to 1 concepts,
Zero
right
to
now?
one, yeah, that's a power law, exactly. So there can be 10 times as many that are 10 times smaller. There's actually thousands and millions of times more that are the fraction of a width of a human hair, but they're all in space too, from the same supernova that blew up in our local corner of the galaxy 5 billion years ago or so. Those are still in our galaxy, and there's many of these supernova throughout our galaxy. There's about one every 100 years. So the Milky Way is over 5 billion years old, 6-7 billion years old. So there's been many times for these 100-year periods to produce a supernova to blow up.
Yes.
So this particular phenomena then can these little grains of iron can get aligned, but there's a magnetic field in almost every object in the universe. The Earth has a magnetic field. Our bodies have a slight magnetic field. The galaxy, the solar system has magnetic field, and that can align these tiny little microscopic grains of dust made of meteoritic material in space and actually produce the same pattern and mock and mimic it, exactly what we were looking for. And that's what we saw. We saw dust grains in our galaxy. So it wasn't like a thumbprint. We didn't leave the lens cap on, in the thumbnail.
It wasn't stupid. It
wasn't a
natural.
blunder. Yeah. It was an astrophysical phenomena, and it just wasn't a cosmological phenomena.
How did you figure that out?
So we worked with our critics, and this is this hallmark of good scientists, that there was another experiment that were our arch competitors, our nemesis, called Planck. And Planck was a €1 billion experiment launched into space with parts built by my late advisor, Andrew Lang, and Jamie Bach, and other people that were members of the BICEP team. And they had done this, mainly led out of the European Space Agency. George Sadiu and many other great scientists worked on it for many, many years, launched into deep orbit, 4 times the distance to the Earth to the moon, beyond the orbit of the moon. And they launched this telescope, and they had data that we lacked. And the data that they had that we lacked was exceptionally accessible and exquisitely sensitive to dust, not to the cosmic signal as much as we were, but to the dust signal. So what we saw, and Stephen Hawking used to say, every equation cuts your readership by half. So I won't do any other podcast equations. I don't want to cut the listenership by more than half, but I'll have to do this. What we were seeing was the combination. Imagine the signal S that we saw was the cosmic signal C plus dust D. Okay, so S equals C.
It's actually not that complicated.
Plus D. Okay, but now it's going to get complicated because we have to invoke subtraction. Addition's tricky, pal. So then we had from the Planck, our competitors, trying to see the same thing, trying to win the same Nobel Prizes as us. They could measure the dust signal. So then we took their data in combination with us. They originally wouldn't give it to us. It would have helped if they gave it to us, 6 months earlier. We wouldn't have put out this, publication that led to this press conference that led to us being on the front page of the New York Times, and other things. And then we wouldn't have had to retract it. Of course, I wouldn't have written my book, but that's the way life goes.
Life works out okay.
So they measured the D signal. We combine it with C plus D, or we subtracted it from C plus D, and what's left is C. In other words, you need another experiment. What was that like in the analogy when I said you put your thumb on the lens? That means that somebody else did another experiment. Your competitor said, "Hey, Julian, look there. There's a thumbprint on your lens." Technically, it's another experiment. Oh, okay. Let me wipe it off. Now I removed the dust signal or the fingerprint signal, and what's left is the pure signal, and that didn't have any evidence for the gravitational waves, which would have meant inflation took place, which would have meant that we live in a multiverse. So now it
would have meant we lived in a multiverse.
Yes. It's almost impossible to have inflationary gravitational waves present if the multiverse is also not similarly true.
Why is that?
So this is a big
define multiverse for the people out there who aren't familiar.
So Copernicus and Galileo and others came up with the idea that the Earth is not special. The Earth is just one planet. It's not even the center of our solar system. The sun is the center of our solar system. Later astronomers came up with the idea that the solar system is not the center of the galaxy. Later, people came up with the notion that our galaxy is just one of other galaxies and it is not in the center of the universe. And the natural extension of this Copernican reasoning is that we are not the only universe in a greater, vaster cosmos called the multiverse. The multiverse is, depending on how you get to define it, there's multiple multiverses to make things super confusing.
Is it multiverses or multiversi? I'm so bothered by this. There's
Well,
so
if
many
you talk
words
to my
like
friend
this.
Andrew Huberman, he'll say it's octopuses, not octopi.
Octopussies?
Again, wait a second here. Hold on. Heyo. Howard Dorey show. So when you look at the progression, it's not out of the question that there could be other universes that we don't have access to. Just like if we go out into the Atlantic Ocean, go off Long Island, and we go fishing, we can't see land, but we could hear, let's say, there's a fireworks show or somebody drops, something, or a boat crashes, in the harbor. We can see the waves coming from it over the horizon. That gives us information about what kind of boats they were, how fast were they traveling, an angle did they hit each other at.
Again, a tough look for the flat earthers.
Exactly.
Yeah. They're just taking a lot of L's today.
So when we look back into the history of cosmology, what we see is that the only way that you could get inflation to spring forth from nothing, and literally a universe from nothing, would mean that there are other potential universes that could exist and that we could someday obtain evidence for. And in that sense, I think it's interesting to note that if we don't get evidence for it, it's not proof that the multiverse doesn't exist. It's not proof that the universe didn't begin with inflation. It's merely a statement. Again, what we're trying to do is prove things wrong, not prove things right. So you can't prove the multiverse is true. You can only prove that a theory that doesn't have, say, gravitational waves is false by observing gravitational waves.
If you had proved that there was a reasonably high expectation based on the data that the multiverse system existed, would you have at the same time been able to say, therefore it is possible to and probably has been done before, to traverse time?
So
Time
not
travel.
necessarily. No, they're not necessarily related to each other.
Okay.
So it could be that there are other. Remember, there's different types of. When I say there's a multiverse, there's not just one type of multiverse. There's a multiverse in quantum mechanics. It's called the many worlds interpretation, popularized by a physicist at Princeton, of course, as many great things that came out of New Jersey.
A lot of good stuff in Jersey. Man.
I know.
This is where Einstein was too. Don't forget that.
Einstein, John Archibald Wheeler was here. Feynman was here.
Great state, man.
Yeah, I didn't know.
I'm going to sell you on it.
I
gonna get you out
I spent
here.
a summer in Spring Lake. I enjoyed it.
Okay.
Asbury Park. Yeah.
Good spot.
Point
Good
Pleasant.
spot.
Point Pleasant.
Absolutely.
Great place
A lot of
to
good
be.
bars there.
Well, I was too young.
Were you a fighter back then?
What's that?
Were you a fighter?
No, it's
Brian Bar fighter?
that's right. No, I was not as a 9-year-old.
They love throwing hands
Just with my
around there.
brothers. Yeah. So when so it's basically a concept that in quantum mechanics, you've heard of Schrodinger's cat.
Yes.
There's a notion that
Talked
this
about that
cat.
with Michio.
Oh yeah, right. So the notion the cat in quantum mechanics can be represented as a superposition of two different completely orthogonal states that are only revealed once an observer makes a measurement.
I should have said this a lot more times today, but in English now.
Okay, right. Well, I can do it in Hebrew if you like. I can.
Let's start with English. We'll work our way to Hebrew.
So what there is in a famous paradox called Schrodinger's cat. Quantum mechanics is a description of the most tiniest abstract element building blocks of nature called particles. And these particles, the most common ones that we deal with are electrons, as I said, and subatomic particles like quarks. But the classic one is an electron. Electrons only have these three properties: charge, mass, and spin. And they're described not by the laws of Isaac Newton that describes, force equals mass times acceleration, how things fall, gravity and stuff. They're described by an analogous equation called the Schrodinger equation. The Schrodinger equation predicts in some sense the probability that you'll find an electron at a given point in space at a given time that the measurement is done. But the key is that these objects evolve, that the state of the electron behaves sort of like a wave where there's an oscillating probability to find it at this state in a given place at a given time. And that it only depends on the interaction between the thing that you're describing, the electron, and something has to observe it. And when you observe it, you so-called collapse the wave function in what's called the Copenhagen interpretation of quantum mechanics. Unlike classical, we don't have an interpretation of classical mechanics. You don't say, well, in Newton's laws of acceleration, force equals mass times acceleration. But in Keating Kaku theory, it goes like, mass equals this cube root, or whatever. We don't have to interpret it. Like, what is the meaning of position? No, we know what it is. But when something's like spread out, and diffuse, and is only probabilistic, then you have to ask, well, like, does this thing exist when I don't look at it? Einstein used to ask, like, does the moon exist if you don't look at it? So there's an interplay that you don't have, because in classical physics, I can look at this object moving through space, and I can plot it, just from the camera, there it's moving, as I drop it. And then I can construct, did that fall at 9.8 meters per second squared under the force of gravity? Did its velocity increase 9.8 meters in the first second? And you will obtain that just from looking at that. What's happening when the camera does this measurement? There's lights in the room.
Yes.
The lights are bouncing off of here and going into the camera and a sensor in the camera. And there's a time clock in the camera's built in, and you can see how many frames it took to fall, and you can measure it really accurately. Well, what if I reduce this down to the size of an electron? Okay, let's do the same experiment. Let's drop it. It should, in abstract sense, fall at the exact same rate, 9.8 meters per second. But wait, it's not a point. It's not even a well-defined boundary or border like this meteorite has. There's a fuzzy probabilistic cloud. That's one problem. Here's another problem. When the lights from the overhead lighting rig, the very expensive and incredibly beautiful lighting rig here in the studio, when they bounce off the electron, that changes the path of the electron, because they have a lot of energy and momentum compared to the size of the thing you're talking about. Unlike this thing.
This thing doesn't change that at all.
You don't change
not even one micro.
Not
something
even
we
at
can't
all.
say.
No, because in fact, there's probably equal pressure from the vast amount of other photons that are also hitting it from other directions. So and then you could say, well, what if I don't look at it? Well, that could not affect its properties. No, the best you can say is there's a probability for it to behave just like it's a brick falling or a meteorite falling through space. And so what there is in quantum mechanics is this interpretation. You have to say, well, when I look at it, what happens to its position and momentum? Here's another way to think about it. Imagine you're in a room and it's completely dark, and we put on this table here a ping pong ball, and I tell you it's moving around. And I ask you, Julian, tell me exactly what its velocity is and tell me exactly where it is. How would you do that? Just with your hands.
Oh.
So here's the ping pong ball. It's rolling around in here.
I would do it by pointing, but you wouldn't see me hypothetically.
No, it's totally dark. It's totally dark. Yep. So how would you do it?
I might use like sound to be able to show you it's rolling from here to there.
Okay.
Something like that.
Let's say you do it with sound. Echolocation is what it's called. Another way you could do it is, let's say, close your eyes, it's moving around, and you put your hands around it, and you keep making your hands smaller, and then finally you measure it, right? So now I measured it. I know exactly where it is. But what do I know about its velocity? I don't know anything.
Well, that's what I was saying. Okay.
But even with that, you're hitting it with sound waves.
Yeah,
it's changing its velocity,
it's guesswork.
Right? So the lighter and the smaller and the less massive these particles get, the more you disturb it by doing a measurement. So what Schrodinger's cat kind of attempts to say is that in one interpretation, the cat could physically be represented as a living cat and a dead cat. And the cat dies, by the way, of when you, every so often there's a radioactive beta decay, nuclear decay that shoots and gets detected by a Geiger counter. Here's a click. It breaks open a capsule of cyanide, and that kills the cat. The question is, what is the cat's state before you open it up? Because the decay of radioactive nuclei is purely quantum mechanical. There's some way, it's just like the electron. But the cat's living or dead is a classical phenomenon. All the molecules of the cat are dead or alive in this scenario. So when you open the box, you look at it, you collapse the wave function, and you force the cat to either be alive or dead. So that's in the Copenhagen interpretation. In what's called the many worlds interpretation, the cat in one universe goes and is off in the living state for all time. You never collapsed it. It never changed. It never was dead at any time or superposition. It doesn't have to be in a superposition. And in the other one, it goes into a state where it's dead. And that's in another universe, it's dead in that. So there's a multiverse of quantum mechanics as well as a multiverse of cosmology. And yes, it's more complicated than all the Marvel movies written with the word verse or multiverse or Spider-Verse. Yeah, it's very complicated, but it's very interesting. And again, the reason that these stakes are so high is that because if we had observed these waves of gravity, if we had been verified, or if my future experiment, the Simons Observatory, does observe these conclusively, again, it doesn't prove, but it gives credence to inflation. And inflation comes, as a big word, concomitant. It always comes associated with the multiverse. In other words, it's almost impossible to have, and you can talk to Lawrence about this when he's here. It's almost impossible to have inflation without having the multiverse. So therefore, the stakes get even higher, right? On one hand, we would have detected gravitational waves for the first time in this way. That won a Nobel Prize 3 years afterwards, what's called LIGO. And then it would have been a detection of inflation, which is the spark, the match that ignited the Big Bang. That's like a second Big Bang, a second Nobel Prize. And then it would have been indirect evidence, as I say, for the multiverse, which, who knows how many Nobel Prizes that would have been worth.
How many years of research from the first time one of you guys thought about it in a room to the moment you guys figured out it was wrong went into Bicep?
15 years and probably $8 million and many trips to the South Pole and many people's career. But again, it wasn't wrong. And actually, it is the best experiment still of its kind ever done, even better than my current experiment, which is the Simons Observatory.
It wasn't wrong. You just weren't able to observe what you were testing.
We observed exquisitely, measured the properties of dust in our galaxy. So in that sense, what we had claimed was we had observed the ignition of the Big Bang, the inflationary epoch.
Do you believe that still exists and is out there, but you guys just didn't have the ability to see it?
Again, I don't believe in things, right? We ask what we have evidence for. And so we don't have evidence for it yet. We have circumstantial evidence that's very strong, that's suggestive of the fact, or else we wouldn't be building the experiment, that the best, the explanation that seems to explain the most disparate phenomena is inflation, but this will be the smoking gun. In other words, you come to the scene of a crime and you're like, there's a dead body. How did he die? You don't know. But if you see there's a gun and there's smoke coming out of it, these waves of gravity are like the smoke from that gun. And so if we do see it, again, it doesn't prove it, right? He could have also been poisoned and then shot, whatever. I don't know what you guys do here in New Jersey, but we're not going to get into the mafia or anything like that. We have our own mafia and cosmology. So yeah, I think but it would be strong, and circumstantial evidence is evidence, right? You can't dismiss it. But you can't also say it proves once and for all. But for most people, this is the holy grail for the type of cosmology that we're doing, which is why, these agencies have put $100 million into building this instrument in Chile, which is now the focus of my career and probably will be for the remainder of it.
What was that moment like when you realized you were observing dust, and how quickly did it happen?
That's a great question. It was always a question in the back of my mind and all of our minds. I mean, they're all great scientists. I had been sort of removed from the leadership of the experiment after the suicide of the principal investigator of it. It was my mentor, Andrew Lang.
Oh, he committed suicide?
Yeah. So
I'm sorry to hear that.
Yeah. So he committed suicide only a few weeks after we had gotten the instrument working at the South Pole, and it was just a tremendous. But he was like a father figure career wise to me, and he would also, he was a very good personal friend of mine, and I was very devastated by it. Left behind 3 kids and just a hole in millions of people. I mean, he was like the quintessential uber scientist. I would say look, remember that guy Mad Men? What's his name? John Hamm. He's like just
Don Draper. Yeah.
Don Draper. Yeah. He's
right behind you.
Super. Oh yeah.
Pictures right there.
Oh yeah. There he is. Right. So he was just handsome and brilliant and surefire. He was going to win a Nobel Prize. His widow ended up winning the Nobel Prize in chemistry a few years ago after he died.
Wow.
Different. They weren't working together, but no, they're just power couple. Beautiful people, beautiful family, and nobody expected it, I think, and it's just completely devastating to anybody that knew him, and cast a pall over the whole project in a certain sense. But by the time we had gotten enough data to say once and for all that we had detected this pattern, and ultimately we did detect the pattern, and the pattern is more significant than ever, and we know it more accurately and more precisely than ever. We just know that it's not necessarily from the cosmos, but rather from our galaxy, which is interesting, but it's not significant in the sense of, understanding how the universe began. So I'm not affiliated with that experiment anymore, but it's gone from Bicep 1 that I co-invented all the way up in 2000. You asked me how long it was. We started in 2001. And we built, and this announcement was in 2014. So that, 14, 13 years. And then the retraction came sort of 6 months later. We didn't retract it. We said we rescinded the interpretation that it came from the origin of the universe. And we said the most likely explanation is that it came from dust. And the only way we could do that is by working with our former competitors on this Planck billion-euro satellite that was launched a few years before, we made these announcements.
Was there any sort of, I mean, you had called them like, you use competitors there, but you had called them critics earlier. Was there any sort of like intense behind the scenes, drag it out arguments after this came out, or was it more you guys were all just looking for the truth and wanted to team up and do it?
I mean, I've been kind of surprised how little blowback we've gotten, or the leadership. Again, I didn't make the decision to have a press conference and, go to the New York Times and so forth. Even though I had started the predecessor experiment and I was still involved with it and my students were still working on BICEP 2. So those decisions and so forth were made under the threat of pressure that we would be scooped in this discovery by this Planck satellite, which had claimed that they were going to beat us, and they had all the budget and a much bigger team than we did. And they were in space, which is, for technical reasons, much better than being even at the South Pole, which is a great location for doing this type of work. So the critics came in a variety of forms. So we published this paper online. It wasn't peer reviewed when we made the press conference. That's how nervous the leadership was about getting scooped by Planck, and that they wouldn't share their data with us before release also probably gave them some concern that they were about to get scooped. So they went ahead and published it, and it was actually not peer reviewed for many months afterwards. And then a few months after it was peer reviewed, accepted, and published, then it was basically retracted by working with these with the former competitors. So, but there were other critics that were, basically saying that we had made these flaws and made basically blunders, not astrophysically wrong, that we had basically done bad scientific research, that we were wrong and not good scientifically.
Thumb on the camera.
Yeah, basically that we just totally overlooked the most basic, Astro 101, flubs and bloopers. And they were just critics. And I would say they don't count. And so that's the critic in the, that's not in the arena, right? But, it's better to own the telescope and own the arena than to sit on the sidelines, throwing rocks of dust at you.
Yeah. And what you had hinted at it a few minutes ago, but what are you working on now?
So once you realize that the signal is going to be accompanied by this imposter that can mimic the signal that you're looking for, it's kind of like fool me once, shame on you, fool me twice, shame on me. So now we're aware of it, we're on notice. So every experiment that's looking for the inflationary gravitational wave background, the signal that could be the harbinger that inflation took place to ignite the Big Bang into propelling the universe to expand for basically the foreseeable future. And that comes, as I say, concomitant, big word, but it's very descriptive, with the multiverse, that you basically cannot have the inflationary gravitational waves without the multiverse. Now all hands are on deck. So now we embedded in our team people who only focus on dust, and in their team too, on the BICEP team, which is now called BICEP Array, the fourth generation of the BICEP program. So they have people that really just focus on modeling, understanding dust, understanding the magnetic field of the galaxy. Are there other experiments from, like, say, an optical telescope? So the same dust that emits these microwaves that confused us also obstructs and blocks the light from stars behind the clouds of dust in our Milky Way galaxy. So we're working with optical astronomers. We're working with people that look at the magnetic field of the galaxy, because that's what aligns the dust. And we're looking at people that build radio telescopes at very high frequencies and very low frequencies in order to get more information only about dust and contaminants. So now what BICEP couldn't do, BICEP Array and the Simons Observatory are now doing, both with collaborators external to the project. In other words, different teams using optical telescopes, which have nothing to do with what we're doing, looking at starlight polarization and the light of stars, and people on our own team that are building channels and aspects of our experiment that can only see dust. So we have internal calibration tools and external calibration tools, and those are all to remove the systematic thumbprint on the lens, so to speak.
Wow.
Yeah.
So it's amazing how long this stuff takes. I mean, people spend their whole, like we've been saying, people will spend their whole life working on one thing.
But that's what makes it so exciting, and that's why I think I like, to study both the biggest picture things in science, which, this type of science that I get to do unifies the physics of the very small with the physics of the largest thing imaginable, the multiverse. It even has implications for the existence of life in the universe, for consciousness, and for the wave function of the universe. Is there a conscious observer? Now you start to dovetail into theological consideration. I mean, to me, it's like I'm a kid in the intellectual candy store. So I never get enough of it. I never want to retire. It's so much fun.
Yeah, it's so like these are the kinds of things that when I was a kid, if it wasn't bouncing a basketball or throwing around a football, like I didn't care that much.
Right.
You know, like I look at physics now, I just wasn't interested in it when I did it. And
You're
then
right.
when I got into my 20s, I'm like, oh my God, this is so fucking cool.
Don't make the mistake, Julian.
Yeah, don't make that mistake,
Go to
everyone.
relativistic astrophysics graduate school before you start a podcast.
Go do math and science before you start a podcast.
I'll endorse that. Doc, I'm a doctor.
It's
9 out of 10 doctors agree with that.
It's really like when you think about the patterns of the world, and you were reminding me of this earlier when you were talking about that object in your hand there and about how there is, I'm going to get this wrong how I say it, but there's basically like more massive things that happen at the top and then it trickles down and opens up at the bottom.
Yeah, parallel,
and then you think about like our parallels as to how the world works among us 8 billion humans, and you have the people who are rich at the top all the way spreading out to the people who are poor at the bottom. These
80-20, right. Mm-hmm.
Exactly. These numbers and these patterns of how things are distributed around the mean, they exist universally, and they exist here just in our little bullshit behaviors together as humans.
Yeah, and you start to see connections, and that's part of the job of a scientist, is to notice anomalies, patterns, things that don't fit in, seek them out, try to explain them with existing understanding, technology, tools, and data, and then where not possible, extend by making new laws, new ideas, new hypotheses. And I think that that's a healthy sign of what makes humans unique, is that we have that capability to do, with our frontal cortex, to think about experiments that aren't yet done. Like most chimpanzees are not doing like thought experiments. Like if I drop an apple on top of this beehive, it'll hit at the beehive with the same amount of speed as a hitting it with a giant rock. But I should hit it with, they're not doing these thought experiments. We are. And just the capacity that we have to imagine scenarios is just, quite frankly, something that we should all have a little bit of cosmic swagger over. But I always say, there's a quote from the Talmud that you should have 2 pockets, and in your pockets you should have 2 pieces of paper. One that says, the whole universe was made for me. That's the swagger. Like it's my playground. It's my delight. It's my garden of heavenly paradise. And I can find things that give me beauty. And I would say like we could be like bacteria in a petri dish, right? Bacteria are eating agar. Like, have you ever tasted agar? No, I don't think, picture like the worst possible, gelatinous, non-flavored. It's just purely to get them to grow and make colonies and so that scientists can study them. That could be whatever, like instead of delicious coffee and the mixture with the cream and then, just the incredible flavors and then the visual sensation that we have a spectrum on our tongue and we can taste these different things and we can see different colors and people and interact with them in a network, and that gives us happiness. So the whole world was made for our pleasure in that sense. On the other hand, you should have another pocket with a piece of paper that says, we are nothing but dust. Basically, our future is dust. We came from dust. We're nothing. We're cosmically insignificant. And
dust to dust.
Yeah. And how do you balance that? How do you balance the humility with the swagger? Because you can't do good science if you're only just purely, humiliated, humbled, and just have this fear of like, well, what is a person? I can't do anything. And similarly, you can't really expect to proceed flawlessly if you always think I've got this total swagger, I'm the man, I know everything, because we know almost nothing. So balancing those two is a job of a scientist. And I think, besides getting up in, stupid culture wars and political partisan fighting, it's what makes life so exciting and interesting to be a scientist.
That little 3-liner story you had you just remind me of it, about Albert Einstein testing people with IQ. I think I've told that to like 40 people since I heard that. That's one of the best things ever.
Yeah, my father used to say that to me all the time.
Where basically like someone walks in, says to Einstein, I want to talk about science. He goes, great, what's your IQ? He says 140. He goes, awesome, we can talk about string theory, this or that. Second guy walks in, says, oh, I want to talk about science. Einstein says, great, what's your IQ? And he says 130. He goes, awesome, we could talk about relativity, this and that. Third guy walks in, says, I want to talk about science. And Einstein says, great, what's your IQ? And he says 100, and he goes, all right, we'll talk about the fucking culture wars. That is, man, does that explain society in so many ways. Because I know some of it, like, you know, you have to get to, we're talking obviously a little bit outside the scientific realm right now, but, you know, you have to get to some consensus on how to play nice in the sandbox together. I understand that. But we spend so much time bullshitting and fighting over, you know, who tucks their sack back or not. And it just gets so exhausting, and I don't care.
Yeah.
You know, I can imagine guys like you in your field who are busy trying to figure out the most important questions of the world, you know, turn on the TV and hear what these two assholes are fighting about for any given 5-minute soundbite. And you're just like, what am I even doing here?
Wow.
These people are the same species as me? It's crazy.
Yeah, it's frustrating, and I think, you know, the only person you can control is yourself, and most of us can't even do that very well. And I think, you know, to dedicate your time in the right way, in the proper way, and just concentrate forever with meditative, you know, Sam Harris like ability is beyond most people. But I think, you know, to the extent that you can synthesize and harmonize what you do for work, and that you can get meaning out of what you do, and also significance about what you do, I think that's really powerful. I don't think that I would have, you know, I wrote my book long before I had a podcast. But at the same token, I think I get a lot more satisfaction out of those types of things because, you know, for the mere fact that you can spread education, you know, my job, education is interesting. The word education means to pour out of. I'll demonstrate here. No, we would never spill any liquids on this table, right?
We already did that.
So it means to pour out of, not to pour into. Most people think, oh, I'm going to jam all this educated knowledge, this street smarts. You got street smarts, you don't have any book smarts. You know? So pouring it in, no, you're actually bringing out of. But now, who was born knowing, you know, abstract algebra and, you know, relativity and group theory? You know, nobody. You know, so you have to be mindful that you have this opportunity to do it, but you're also not expected to understand all of it, nor are you expected to desist from it. So for me, I often talk to my colleagues and I'm like, why don't you put out a YouTube video? You know, why don't you do something? Why don't you, besides this paper that was read by 6 people, all of whom are your friends or your former students or whatever.
Not everyone's as good on camera as Brian Keating.
But that's not the point. I wasn't always good on the camera either. You know, when my first book came out, I had all my editor at Norton and they were like, oh, you should start a channel and start being an explainer and you could be the next Neil deGrasse Tyson and do all this. And, you know, he was published by the same publishing house, Norton. And I was like, I don't have time for that. I'm a real scientist. I got to work. I got to put out these papers. I got to advise graduates. And I still do all that. But I've come to see that it's my moral obligation, you know, that I get paid to do this job. And it's because of the taxpayers that I get to do it. And every scientist is the same way. And when you hear somebody say that and you hear them say, well, I'm not good at it. And I always say, oh, yeah, I forgot. When you were born, you understood quantum electrodynamics and you understood string theory. No, I had to work on that. Oh, I see. You work on things that are meaningful to you and matter to you. Oh, I see. Oh, so you just saying that's for people like Neil deGrasse Tyson, who most scientists don't have a lot of respect for. Oh, he's just a popularizer because they're just like he's not an active science. He's not advising, you know, writing papers and doing research anymore. He has a PhD and he was trained in it, but even he will say he's not an active scientist. And to give him his credit, you know, a lot of people don't. I just saw him on Bill Maher, and Bill Maher was like going off on him for being, you know, less than forceful in regards to college campuses. But it's funny here, Bill Maher and going off on him, But Neil will say, you know, if you come and ask me about what's the latest development in string theory and, you know, and whatnot, he'll say, you know, go talk to Brian Greene or, you know, an active scientist, not me who's doing star talk and popularization. So I have respect for people like that. But to say that you can only do that, only do outreach and do a podcast or make a video or TikTok or whatever, if you're Neil deGrasse Tyson, who I don't respect because he's not a real scientist, is what people say, not me.
Then go do it your damn self.
All right. So that's true. And but by the same token, what if they would say, well, I'm not Einstein. So I'm not going to even start doing Well, Einstein wasn't always Einstein. You know, he wasn't always, the God equation. You know, and Kaku wasn't always Kaku, and Weinstein wasn't always Weinstein, right? So from this perspective, if you start off with this again, the humility has to be balanced with the swagger. I have the same number of chromosomes. I have the same number of muscles and body parts. That doesn't mean I'm going to be Joe Rogan in the ring or as a podcaster. But if I say I'm not going to do, because I can't be the best at it, I'm not going to do it, or because it's hard for me, that's the joke to me. It's like, yeah, well, so is like, going on a diet, or so is, teaching your 5-year-old to ride a bike. These are not easy things, and humans have to be generalists. We have to know a lot about many different things. We're not insects. Heinlein said, we're insects, or for specializations for insects, not for human beings. So you should be able to change a diaper, write a novel, fight in a war, and, in my case, look through a telescope.
Yeah, I've never really bought the argument about not being able to teach it and that whole rivalry that happens, because someone has to get kids in this country interested in this stuff again too. You got to get them dreaming and asking the questions we used to ask when we were young, like what are the stars, what's going on in the sky, and also what built a lot of this country. I mean, we just had a movie come out over the summer, Oppenheimer, about the guys who invented the nuke during World War II, which effectively ended that thing. I mean, physicists and science are at the middle of everything that happens. And so, I've heard that criticism like a lot with Kaku, but like a guy like that, forget Tyson for 1 second, but like Kaku spent years doing science, and now, say for the last 2 decades, he's focused very hard on being, as he describes himself, a popularizer of the subject. And what I like about him is he will take a lot of complex things and make it simple. He will make it fun. He'll tell a story with it. He knows very well how to explain some of this stuff, and he'll do it 100 times over, so that a kid can be like, oh, that makes sense. You know what I mean? And so we have to celebrate that. We should be celebrating both. In my opinion, we should be celebrating the people who are trying to break those frontiers right now, which is not necessarily something he's actively trying to do anymore. Yeah. And we should celebrate the people who are getting kids to go, wow, this is cool. I enjoy that.
Yeah, but of course, the subtext that I'm going to push back with my rugged good looks and handsome criticism, but I always criticize with love. But I actually think that's kind of, they call the benign bigotry of low expectations. Like if you say, well, you stay in your lane, which is, distillation of what you're saying, I think it does some damage, not only because you would have, you wouldn't tell, like, imagine you meet some cool, smart, young, girl, and she's into YouTube, and she's really into YouTube, but she wants to be a physicist. You wouldn't say, well, like, just keep doing the YouTube thing and don't go to graduate school, or don't go, right? So you wouldn't tell her to stick in her lane. So I guess but also for my students that are, many of them, I've had 40 different students from foreign countries and all around the world, every continent, including Antarctica.
Really?
I've had students on, yeah.
From Antarctica?
Well, they weren't born there, but they lived there for many, many months, yeah.
Where do you even live?
That's where we live. So I described it in my book, Losing the Nobel Prize.
Interesting.
So yeah, one of my students lived 6 months at the South Pole. Basically, he almost became a permanent citizen.
6 months. I mean,
okay. You think Hoboken is exciting? You wait till you go to the South Pole, baby. But these students, they get an exposure to another dimension of their persona, their ability to communicate. If you can't explain it to, as the stereotypical grandmother, then you don't really understand it. You may understand it, but you may feature what Pinker calls the curse of knowledge, where you're just so erudite and so brilliant, you can't understand what it's like not to know something like that. You may get so siloed, and you just talk in an echo chamber of academia that you don't know how to relate to a common person. I always say, like, imagine you came up, you're hired, a producer for the show, and you say, I want you to do X, Y, and Z. And then maybe they do it and maybe they don't. But whenever you ask them what they do, they say, oh, you can't understand what I'm doing, Julian. You think you can understand with the magic that I am I'm so specialized, these tools and techniques and behaviors that I have manifested. You'd be like, I'll go and get another producer. Like, you're going to treat me, that's a chutzpah. That is not acceptable. And yet we let scientists do that, basically saying, like, if it was, as Feynman used to say, if it was easy to explain to you, it wouldn't be worth a Nobel Prize. No, I think you really don't. But he would also say, if you don't explain it to your grandmother, you don't understand it. So we have to balance that, but we shortchange our students by not forcing them to. I had this, online argument, I guess, with this guy, Brent Hull, I think, Brett or Brent. Anyway, he wrote, he does all these podcasts with Naval Ravikant, and they're BFFs, I guess. And he was, oh no, like it's the opposite of what you did, like you became good at podcasting, and then, after you were a scientist, now you're telling people not to do that. I'm like, what are you talking about? All I'm saying is it's good for your students to get exposure to public speaking. One of the things I do for my students that come from foreign countries is I pay for them out of my own pocket to go to Toastmasters,
Oh, wow.
Just like what are they going to, like they came from Thailand or China and they're now learning to speak, and maybe their accent is still going to be just as strong, but they're going to be comfortable making a toast and making a joke in public. You know how much, your first podcast is probably unwatchable by you, right?
Oh
Mine is like that too. So you get those at-bats out of the way early on. And then when they do have to speak and they're speaking for their career now, having the background where they got, they made the mistakes on a podcast or on a TikTok video where 90% of young people are getting their news. I don't get into, I have a small TikTok following now. Small, like
what's the at?
Like
at Brian Keating?
At Professor Keating. Yeah.
Professor
Brian
Keating.
I had Dr. Brian Keating,
Ooh.
and then I lost access to the phone that it was associated with.
God damn it.
I talked to President Xi in China and he pulled some strings, but it didn't work. Anyway, so I tried Professor Keating. Yeah, exactly. But I just put my YouTube shorts on there basically.
Gotcha.
So it's fun. You can find it on YouTube, even better. But anyway, it's a whole new dimension of my personality. I wouldn't have known about it if I didn't try. I was scared the first dozen times I did podcasting. And also, there are perishable times, and like you might not ever be able to get Kaku back again. I don't know, maybe or me or whatever. What I might move to Nobel, to Stockholm or something. All right, so who knows? And you only do things in person.
Right,
So
I'll fly from Stockholm.
You basically get a couple of swings at the bat, and you don't know if you're ever going to get that chance again. So if you're talking to somebody. It's risk taking. It's a whole other, side of organization, public speaking, communication, explanation. Some people I work with are not good on camera and they want to do animations. That's super cool. Like for a kid to do like research, and not even a kid. I have some adults that just volunteer. They make animations for my explainer videos on YouTube because I do explainers and podcasts, which is probably why the algorithm has no idea what to make of the Dr. Brian.
I like that. Keep doing that.
Yeah, it's fun. And I'm going to keep doing it. I've tried to be divorced from the hedonic treadmill of, how many subs, how many likes, comments, and stuff like that. It's impossible to be completely, separated from it because, and I should say I don't get, the lion's share of my income from the podcast, but I make a decent living. I could subsist on it if I needed to. With
you have a way better setup how you're doing it though, because you have the career, you have the legitimacy there. You make your money. Right. Your podcast scratches your itch of your interests.
It's safer for me than it is for you. I admit 100%. But Julian, there's 47 other. I shouldn't even say because some of my colleagues do listen to all the podcasts that I go on, and they're looking for little nitpicks with me. But I'll say there's dozens of colleagues that aren't doing it. And there's more that aren't doing it. But even not doing it, I don't even mean start a YouTube channel. Just go on other people's shows. Yes. You have a paper that came out. Why did you publish this paper on this type of weird liquid crystal that behaves with a certain property when polarized light is exposed to it? Okay. It's very arcane, very abstract. But someone's going to be interested in it. Some little Brianna or Brian is going to hear that and say, wow, like I'm really interested. I never knew how that worked. And if you're really good, you'll explain it in terms of something, well, like your iPhone is a different type of screen. And it's totally different than cosmology. I admit cosmology, aliens, consciousness, those are the biggest topics I can think of studying, which is why I focus so much on them on my podcast. But there are other things, and a good guest, as you said, you get people to come in here that maybe aren't the most famous, blown up people, the Hubermans, the, whatever, but you get them on the show and they tell stories and they're good storytellers.
And then they get there. That's what happened to Paul Rosalie.
That's right. Yeah.
That's what happened to Andy Bustamante.
Yeah. Exactly.
And yeah, and
by the way, you're doing a kindness, a hesed, as I say. You're doing a kindness for them because who knows if that's part of their future second mountain, their career, part two. And to not do that and not go on other people's podcasts. I've had on like the most dry, boring. If you read his papers, you'd be like, this guy is, and he's super cool and interesting. Yes. When he talked on the podcast about superconductors and room temperature superconductors, and that was his first podcast. He asked me recently, when am I coming on again?
Because you can bring it to life.
It's fun.
You can bring it
because
to
I'm having fun.
life.
You cannot beat somebody. I had Gad Sad on my podcast recently. He's another great guy. You should have him on. He's up in Montreal.
Is he the mind virus guy?
He's the parasitic mind. That's right.
The parasitic.
He's got a big YouTube channel, large Twitter following. And he was basically, he's basically like the happy poet, the happy warrior. And I said to him, like, you have all this vitriol. And like after these attacks in Israel, he's Jewish. He came from Lebanon as a refugee.
Mm-hmm.
How do we maintain happiness? And he's like, if you're not happy, you're losing. Like if you're not doing it. And there's an old quote, like, you can't beat the guy who's happy. Like these people that come out after Eric or whatever, like Eric is a happy guy most of the time. The weight of the world he weighs on his shoulders, I'm sure too. But he's enjoying, he just loves it. It gives him pleasure. And people like that, people like Feynman, people like Einstein, people like Kaku, they're having fun. You can't beat people like that.
Yes, that definitely came across. And it comes across with you. Like I meet people when they're in here. You know what I mean? It's not just what you see on camera. You get a feel for people.
And by the way, I should say, I don't only, like, if somebody just invites me on their podcast, I don't just go on it. Like, but I've started to do something, and I want to get your feedback and what you think of it. So I'll get people that'll write me, Professor Keating, I love your work. I've seen you on Rogan and Peterson and Friedman and what have you, and now on Julian's podcast. I'm going to get the same. And they're like, I want you on. And I look at their channel and they got 3,700 subscribers. So I'll say, great, I agree to come on, but I'm going to set you a stretch goal. I'm going to give you some homework. I'm a professor. When you get to 10,000 subscribers, I'll come on. I've had people reject me as you've had people reject you. I'm sure it happens all the time. But you give them an achievable goal that's, not 10 orders of magnitude. It's not like detecting the Higgs boson on their YouTube channel, but they're going to do something. And then they come back. And I've had this now at least twice where they come back. I hit it. I'm so glad you told me to do that. And guess what? I had people tell me to do that. And that's people that even did it to me and said I would come on and didn't come on. But that's another story. So you have to be prepared for it. But it gives you ambition, goals, and it forces you to up your systems and learn all the tricks in the trade. And to me, it's all about improvement of the human condition. I think science is the clear-cut tool that will allow us to do it the fastest and most efficiently.
Absolutely. You have, as you mentioned, talked about some of these major topics, though, on your channel with guests and yourself, whether it be consciousness, the beginning of everything, which we've talked about a lot today, but also you mentioned aliens in there.
Yeah, that's a requirement in podcasting in 2023. It's a
total fucking requirement now. But, I have so many open-minded thoughts on that. And you want to talk about stuff you don't know. I mean, my God, the whole thing is stuff you don't know. But we've seen a lot of news this year. We've seen congressional hearings, which in many ways are unprecedented as far as the scale of what we saw this year with Grusch and stuff like that. But as a scientist, have you seen anything that points to, I'm not going to say definitive proof, but strong evidence to show, first, that A, we are the simple one, we are not alone in the universe, and B, that some of these things that are being reported, the phenomena actually are true and did happen?
Yeah, I mean, the most contentious part of my interview with Joe Rogan was about this topic. And it was interesting because I think there's a lot that we agree on, and then there's a lot that he will just use kind of these tropes and superficial arguments, which I've heard for a long time, which aren't, truly superficial in that they've been attributed to luminaries and heroes of mine like Carl Sagan, which is basically, I call that like the surface area argument. There's so many planets, there's so many stars, there's even more than Carl Sagan ever knew about, when he died in the 90s. And he used to say, if there's nobody out there, it's an awful waste of space. Well, I told you, I've been to Antarctica, and I've been there twice, and it's not a very happening place, and it's not happening in a lot of different ways. One of which ways is that there's about 300 people there in the Antarctic winter, which is, our summer in the northern hemisphere. There's about 300 people on the whole freaking continent.
Are there any restaurants there?
There are military bases there, and the military bases supply food, and there's about 12 different countries that have different military bases there.
Are we sure it's just a base? There's not a little something below there? Not like, the descendants of Hitler hiding or some aliens or some shit?
No, they have plenty of places to go in South America, it turns out.
Yes, that's unfortunately true.
Yeah. So when you go there, you basically resign yourself to not seeing any other, people besides the 49 people that might be in your particular military research base, where we go in the United States owns the South Pole because they're doing scientific research there. You're not allowed to mine minerals or construct military airfields there. It's just the military built the research facilities because they're the best for logistics like that. So when you go there, there's basically almost no. Now, not only are the only life forms that you see at the South Pole human beings, there's absolutely no other forms of life effectively. In other words, you won't see birds flying overhead or penguins walking by. The South Pole is 700 miles away from the coast. So it's incredibly remote. And Antarctica itself was only discovered like 150 years ago in the late 1800s. People never discovered it until then.
I've never looked into that.
Yeah.
Now that you say that, holy shit.
They never reached the South Pole until 1911. It's less than 100-year-old, continent and it's just barely been explored. Now, if you just said the same Sagan argument that it's a waste of space, you would say that, well, Antarctica must be a waste of space because there's only 49 people on the whole, 200 people on the whole continent. The whole continent only has 200 people on it. It's the size of like 3 Texases. Okay?
But it's so small relative to the universe.
No, but I'm just saying, just take there's 8 billion people on Earth, right? There's trillions of microbes on Earth, right? Trillions. You're more microbe than you are human,
but
right?
it's fucking cold down there.
But so what? We know what we've learned about life is that life finds a way, right? Like Jeff Goldblum said, life finds a way. Life works. You didn't think about what you should do. You just thought about what you could do. So channeling my Jeff Goldblum.
That was pretty good.
So yeah, we guys stick together. So when you think, but when you make that kind of argument, you're assigning what's called a uniform prior. You're basically saying that like the probability for life should be the same everywhere. In other words, we are a form of life, and then any other planet like Earth should be basically as probable to find life there, right? If I told you there's an identical copy of Earth, forget about like what else is there, if there were dinosaurs there or not. If I just said there's an identical copy of Earth and it's in some other solar system, Proxima Centauri b, okay? And I said, it's identical. It's the same distance from a yellow type star. It's in the habitable zone. There could be liquid water there. There might not be liquid water. It could be ice there. It could not be ice. There could be carbon dioxide. What would you say the odds are that life would exist there? Would you say it's 0? I mean, you definitely couldn't say it's 0, right?
It's not 0.
Right. Would you say it's 100%?
No.
No, so somewhere between, okay? And that's all you can say, right? 0, no life,
you talk
100%.
about not proximate. Holy
right,
shit.
Exactly.
Yeah.
So now you look at that and you say, well, look at the planet Mars. And I made this analogy on Joe Rogan. Mars is right next to an Earth-like planet. In fact, it's very Earth-like because it's Earth. Earth and Mars exchange particles for billions of years. We've been exchanging material. I have a meteorite that I didn't give to Joe Rogan, and I'm not giving it to you either, but it came from Mars. It didn't just come from the supernova that blew up that made this one that I gave you at great cost and personal risk to myself, bringing it through customs. And
I got to put that through something.
Your mass spectrometer here. But despite that, there's no life on Mars. I can say, well, Mars is different. It used to have liquid water. It used to have, abundant liquid water. It still has frozen water. It has carbon dioxide. Was that evidence for life? I mean, if we see carbon dioxide on another exoplanet, we think it's potential evidence for life. Sure. It certainly doesn't forbid it. So for all these reasons, there's some probability that you should say that if life is abundant in the universe, there should be life on the planet literally next door to the only planet we know for sure has life. And yet there's no evidence for life now. There's not even evidence for life that existed in the past. That in itself is not proof that life never existed there or that life couldn't exist there in the future. But again, we can only go with what we say right now. If I put a gun to your head and I said, I'm going to take away all the YouTube Plush Studio and your play button and everything. I said, I'm going to put a gun to your head. What is your factual knowledge, not your belief? What is the evidence for life outside of Earth? What would you say it is? It has to be 0 or 1. What would you say? With 0 or 1?
I don't think I can say 0 or 1.
You wouldn't say 0? I mean, is there evidence for life?
I'm saying if you're saying the answer can only be yes or no, is that what you're referring to there? With 0 or 1?
Yeah. Is there definitely life outside of the Earth or definitely no life outside?
I couldn't say either.
Really? There's evidence for life outside. I mean, have you ever seen evidence for life outside of the Earth? Because I haven't.
That's what I'm saying, though. We only know such a limited amount because we haven't even gone to Mars yet, and it's a planet right next to here.
We've sent rovers and stuff. Yeah, no, I agree. But the fact is we only have evidence for life on Earth. In other words, if I say to you that there's life on Mars or there's life anywhere on any particular thing, it only makes the probability a little bit bigger to say that there could be life. Right? You're basically making this argument that because the universe is so big, there could be life in the universe.
Okay, but what if within our solar system, let's say across our planets, there's no real life on anything else, which is a distinct possibility. That is one solar system in the context of a galaxy, in the context of a series of galaxies, in the context of a universe that we can't even know the limits of. And I've always thought it's incredibly narcissistic to assume that out of everything, this place with the 8 billion people and the lions and the elephants and all the animals and the fish in the water, this is where the life is. And there isn't, forget just life, but there isn't a brilliant life form that exists somewhere else. I find that incredibly hard to believe, also considering the fact that creation had to start somewhere. And why would the creator, whoever that is, whether it's the God that's written in one of the holy books here or something like it or whatever it may be, why would they put, and again, this is an evidenceless comment, to be very clear, just a meta thought comment. Why would they put the only life so many infinitesimal layers away from where they exist? I find that almost impossible.
I think you're over-indexing on the pocket that says we're nothing but dust and ashes. And
how do you figure?
You're saying that we should have humility and say that it's impossible for us to be the pinnacle of creation. Well, who knows? Maybe you should have the other pocket that said the whole universe was made for you, not just humans. It was made for you to do some grand mission. That's the notion of these two pockets. One is I'm nothing. I have to have humility and be humiliated sometimes and make blunders that lose me the Nobel Prize. The other one, I have to say, this is cosmic feast, a buffet of infinite variety that's made just for me. And for me to extract pleasure and happiness and make other people happy and extract pleasure for them. So again, what if I said to you—
Do you think a guy like Grusch is making it up then?
Who? Grusch?
Yeah.
I really have almost no knowledge about him. The stuff that I've seen from American Alchemy, from what's his name? Is it Mitchell? He did an interview on a podcast called American Alchemy, who I'm in touch with. Jesse Michaels or Mitchells. Yeah, he's in LA. I'm supposed to see him sometime. Anyway, he did there are bodies inside and stuff like that. The more precise that you make something, like in other words, I say, Julian, I saw a car go by today, and it was a yellow car. You'd say, okay, well, that's high probability. And then if I say, and there's a Trump rally down the street, and I saw on the back of the car, it had a bumper sticker. It said Trump 2024. Which do you think is more likely to have happened? You just don't know anything else about me. I'm just telling you there's a Trump rally, and that's true. And I saw a yellow car, or I saw a yellow car with a Trump bumper sticker on it going towards the Trump rally, which is happening right now.
Which one do I think
which is more likely? Yeah, which would be more likely to you?
Well, if we know for a fact that the rally's happening, then yeah, that's technically more likely.
No, the more restrictions you put on something, the less probable it becomes, not the more probable it becomes.
What do you mean?
The more kind of boundaries and conditions and specificity that you put on something.
I'm talking about the rally itself.
I know that, but that could be completely irrelevant, right? It could be just a yellow car. Do you admit that there's more yellow cars in the world than yellow cars with Trump stickers on it?
Yes.
So why would you think just because I gave you some additional information, that was really to distract you?
It's I think we're saying the same thing here. Keep going.
You're saying it's more likely that I saw a yellow car that had a Trump sticker.
No.
Oh, you're just saying that it had
I'm saying it's, I think I answered your question wrong because now I may understand it better. Yeah. But what I was saying is between the two events, the rally happening or someone seeing a yellow car with a Trump sticker, which one's more realistic or which one's more likely? Well, I said, well, it's 100% we know the rally happened. They might have seen something wrong if they saw a moving car with a sticker that they maybe didn't see.
Well, it's hard for me to parse exactly what we're talking about, but I'll say this. The more conditions you put on something, the less likely it becomes. Just like I said to you.
Sure.
If I say you weigh less than 1,000 kilograms, it's much more likely that that's true than you weigh 104 kilograms, 0.237 grams, right?
Yeah.
Okay. Yeah. So the more restrictions you put on, the less probable. So if I put more and more restrictions on things like the origin of life and then how did conscious life begin and what properties are required for life to exist, if you look at all the things that had to conspire for us to be here having this podcast right now, there's probably, trillions, if not an infinite number of things, each one of which had almost infinitesimal probability, just
Flap of a butterfly's wing.
Oh, yeah, flap. Well, just look, there are 400 million sperm brethren that you and I beat out, okay? We kicked them out. That's 1 in 400 million shot, right? Literally.
I think it's 4 trillion, right?
No, it's 400 million.
It's 400 million?
Yeah, I don't know about you. You seem young and
only-
virile. I don't
there's
know.
only a 400
us old
million
guys,
shot?
only
Wow.
us old guys. We're talking about 400 million sperms.
Interesting.
So we beat it out, right? So just looking at that, it's right. So any given configuration of probabilities that had to come together is almost zero. But if you start speaking in generalities, the problem comes in, and this is the fallacy that Joe and Carl Sagan and others are succumbing to, who really believe it. I actually don't think Carl Sagan believed it.
You don't think Carl Sagan believed there was life?
I don't think that he would say, well, belief was important to him. It wasn't at all. He would say evidence. So he would say there's no evidence, but there's possibility for it. And so that's where this thing about Mars being next to Earth came in. That's why I brought it up. So if you can't say, again, this didn't prove that life only originated on Earth, the fact that Mars doesn't have life. But if you put a whole bunch of these things together, if you said no star within 70 light years of us has any evidence for extraterrestrial intelligence or life or anything like that, then you say, well, it's only 70 light years within a Milky Way that's 100,000 light years. Okay, keep spreading it out. There are people that do these calculations, and they find the following statistics. And these are people that believe, or if you like, want to believe that there were and are aliens in the universe, civilizations, technological, which I think there's certainly no evidence for any of this, right? I mean, that there are evidence for alien planets. Let's say Grusch is right.
Evidence that you've been able to see.
That I have been able to subject or has been subjected to a scientific rigor commensurate with the scientific method that I practice and my colleagues practice. That's right. Even Grusch doesn't say that he saw it. He says that he knows of people that saw it, right? I'm not denigrating what he says he saw or what he believes. He's certainly more of a hero than I am on a YouTube channel. But for him to come out and say it at great risk, et cetera. But it's not evident. It's not scientific. It's not replicable. It's not falsifiable in the same sense, right? He's saying that people saw it. So I can say that some people said they saw stuff that didn't, I don't have his security clearances, obviously. But look at all these different things that have to come together in order for life to exist on another planet and for technological life to exist and so forth. And I start to think, besides the visitations from Earth, is there any other, which is disputed, right? Nobody's saying for sure Grusch is right or
Sure.
I have it on Ryan Graves, the pilot who, with his colleagues witnessed certain phenomena.
Yeah, I
there.
think he saw DARPA weapons on that one.
It could be. Yeah, he's a very interesting guy, and he's doing good work. And it's kind of like global warming stuff. Like, even if you don't believe global warming is truly happening and it's caused by human beings, reducing carbon emissions will have some benefits to human health and pollution and ancillary, right? So even if Ryan's wrong and they saw DARPA stuff, it'll make the lives of pilots and commercial airline travel and so forth much safer. But I'm really straying far afield. Let me just say this. For us to believe that there is visitation by advanced extraterrestrial intelligences requires a host of different things to have occurred, all of which would make me incredibly excited as a physicist, because it would allow me to short circuit maybe thousands of years of evolution as a scientist. It would just be like string theory's wrong. Sorry, move on to something else. Put more money in cosmology. There'd be so much advancement in technologies. So physicists have a confirmation bias of a vested interest in this being correct. But look at some of the biggest doubters of the extraterrestrial intelligent hypothesis. These are physicists as well. Even people like Avi Loeb and stuff, he won't say that he believes that these are definitive proofs of extraterrestrial intelligence or physics beyond the standard model or other things. He will say that these are things that we need to collect more data on, and that's why he's building these telescopes at Harvard and around the world and trying to collect samples from the bottom of the Marianas Trench or wherever he is. And Papua New Guinea to try to find, the shrapnel left over, because there's so few artifacts. Astronomy, cosmology, searching for alien life is amongst the most challenging things there can be to study. If I want to study some nematode worm, okay, there's trillions of these worms or bacteria. I can do an experiment, pour some, vitamin C on one, don't do it for the other, and one dies, one dies. You can do experiments. How do you do experiments in the cosmos? There's only one, or the universe, one. How do you do experiments with like Oumuamua, which cruise by at, a good fraction of, 10 times faster than any commercial spacecraft that has ever traveled? You can't. It's a one-time only thing. It makes what we do so hard to do. And therefore we project onto it what we want to see. And that's the cardinal sin of a scientist. It's what got me into trouble with the dust findings and so forth. You saw what you wanted to see, or I did.
But let's say you're right in the theory about bicep, which right now obviously
It's
can't
ambiguous.
be proven or
Right.
anything like that. But let's say you are, and you figure out that due to inflation, we therefore have a multiverse. Does that then bring us onto the plane of, when we define an alien, it's just something foreign that we don't think is from this Earth. We don't necessarily know where that comes from, whether it comes from another galaxy and figured out how to traverse wormholes and time and shit like that, or whether or not it could be some sort of future human or some sort of future iteration that exists from the presence that we're in. If you were able to prove that, though, if bicep were able to come through and eventually find the right measurement to be able to find inflation and therefore say, aha, we may have multiverse is there.
Platypi.
Would that then point to the fact that we could have people present here right now who are, as we might know them, half biological entities, whatever they might be, that are those who are future humans who have figured out how to switch between multiverses and or time?
Wow, you layered in about 10,000 different things. Now you're channeling Tom DeLonge on me with the future humans. So I had him on and about 2 years ago, and I'll just say most of my audience wasn't thoroughly impressed with how he acquitted himself. I actually happen to like him. I mean, it's impossible not to like him. And his colleague, Jim Semivan, who's an ex-CIA agent.
Yeah, he's surrounded by spooks, that guy.
That guy. So everyone's like, they keyed in because Jim said, we're the U.S. government. We're not allowed to lie. And the roasting in the comment section was just unparalleled. I'll say this. There is a tendency to kind of project onto aliens a sort of sense of the anxieties, fears, desires, hopes, wishes of our current civilization. And this is not new. This actually dates back to the atomic age, 1940. It's not a coincidence that the first atomic bomb detonation on Earth by human beings was done not far from where Roswell is in New Mexico, or this crash that occurred in 1947, or allegedly had occurred, with alien bodies and alien spacecraft and so forth. Many of these phenomena do occur on military installations to this very day. Many of them are also not only kind of denigrated by people of the scientific community, not saying I never denigrate these people that have more courage in their little fingers than I do in my whole body, but I will say that some of the tell to me, to use a poker analogy, we're not far from Atlantic City, is how are they treated by the people on their colleagues and cohorts? You would think that another pilot wouldn't mock, by putting little green men on David Fravor's pillow or all the stuff that he alleges that they did. And he's correct. I'm not saying he didn't do it. He didn't witness what he did. But these people aren't they worried about encountering these phenomena? If they're really seen every day, as Ryan told me, they're seen every day, and people report cubes and spheres, or spheres and cubes, and that no commercial airliners as yet, and he's working to advance the reporting mechanisms and stuff to destigmatize it. There's a psychological component that's fundamentally not scientific. It doesn't mean that they're wrong. After all, circumstantial evidence on eyewitness testimony, it's a mixed thing. Sometimes it is used in court. Sometimes it's not used in court. Sometimes photographic evidence can't be used in court. And we're getting into an era of deep fakes and so forth like that. So Elon Musk saying, with all these camera technology, shouldn't the videos have gotten better? I think that's a little simplistic too. But what you want to do is not pit natural allies, as I've said, and I find this a lot on my channel. I get comments like this. Of course, you astronomers, you're paid by NASA to have this opinion about that aliens don't exist. Even though I just told you that I would give, I give your right finger to have true evidence, scientific, replicable data from the existence of an extraterrestrial intelligence. That would be more significant than 10 times what I'm doing, I have to say. What I'm doing as a scientist, I would feel like I wasted it, and I would immediately pivot to this. And I'm not unwilling to do that. I've changed my career, from, just being a pure scientist that does nothing else to being a podcaster to being an author. I'm comfortable with making pivots. I'll do that in a reinvention in a second. It has to be warranted. And so don't make an enemy out of scientists who spend their frickin' jobs looking at space in many different domains, from the radio to the X-ray and everything in between, from gravitational waves and then their partners in the theoretical sciences. Don't make enemies out of us just because we disagree with your innate feeling, which is only a feeling, which is ultimately psychological in nature and not scientific, that aliens must exist, and maybe even that I've had an alien encounter. We're not even saying that. Don't make enemies of us. partner with us, work with us, support us, get more funding for research into this. I just had, I'm going to be meeting with my friend David Spergel, who's the president of the Simons Foundation, which funds my research in cosmology. He led the NASA study panel on UAPs. And people came out, oh, he's just he did a terrible job. And of course, he's just speaking the party line, because it came out and it didn't show that there was credible evidence. Even they didn't even say that there's no evidence for it. They just said that 90% plus can be explained by pedestrian means. And he gave multiple examples of these phenomena, from atmospheric effects to government, to spies, to drones, to DARPA, all these different things. He gave examples, some of which are redacted and classified. And there's 10% left over. But that also doesn't mean, there's a 10% chance Elvis is still alive. You can't fault David Spergel. You can't fault the members of this panel, which are esteemed astronomers, physicists, military personnel. You're just fighting a losing battle. You should look for ways that you can get access to the data and then support them. And I'm not involved in that. That's not what I do. I don't do anything related to that other than host people like Ryan and Tom DeLong, and I'm open to it. But at a certain point, there's emotions run so high with this, and I think it has to do with the fundamental, almost quasi-religious belief.
Yes, 100%.
That we are not alone, because it's terrifying, Julian. If we're alone, isn't it terrifying?
It's scary.
Yeah. So I think that animates people. And I'm sympathetic to the people that want to believe, but no scientist should ever say, I want to believe. They should say, I want more data.
That's the thing, though. People aren't just looking for the truth. They're looking for the truth they want to be true. Yeah. And that's at the core. I try to separate all the noise with this whole topic. And there's a lot of different topics I do this with, but on this one in particular, it's like, yeah, it'd be mad interesting if there were a bunch of beings like fucking looking at us or living among us, no less, or something like that. But, I do still believe that it would be questionable to not assume that there's life out in that viciously long galaxy. But the evidence we could have for it here, if someone came up and showed me good evidence tomorrow that nothing had ever been here, I determined it to be like better than evidence I saw to the contrary, I'd take it. You know what I mean?
Yeah.
And that's just the nature of the beast. But listen, I would have a million other things that I want to talk with you about.
Okay.
We're gonna have to do that. This was an awesome conversation. We didn't even get to like consciousness stuff. We didn't get to any AI. We only just scratched the surface of aliens right there. So there is definitely going to be a Brian Keating part 2, but I know you got to go meet with the other Brian Green over at Columbia. Right. But before you go, where can everyone find your show? What's it called and what's it on?
So it's called Into the Impossible Podcast, and on my YouTube channel it's called Dr. Brian Keating, and we cover everything from the brain to the Big Bang, everything in between, from the cosmos to the consciousness. And I am interested in basically anything scientific, because I want to pay back a debt that I owe to my heroes like Carl Sagan, like Brian Greene, like Stephen Hawking, that inspired me that I could become a scientist. And they inspired me not through their scientific papers, which I couldn't comprehend until relatively recently. They inspired me through their popular books. And I endeavored to explain it, never to dumb down. People say, oh, you're good at dumbing down. I hate that. I don't want to dumb down. I want to treat you with respect and say, I'm going to encourage you to have that stretch goal. Like I say, these podcasters with 3,000 subs get to 10,000. Give me something to inspire you. Give me a hook. Give me an in. Once you're in, you're going to get addicted. I promise you, because it's the best script ever written. And we just have to be actors that rise to the challenge to perform this play and the grandest spectacle of nature.
You got a great way of putting things, man. I would, as I said earlier, I'd recommend the show heavily. It's an awesome channel on YouTube, so everyone go check it out. Brian Keating, thank you for being here, sir.
Thank you, brother.
All right, everybody else, you know what it is. Give it a thought. Get back to me. Peace. Thank you for watching this episode, guys. Please make sure you smash that subscribe button, hit that like button on the video, and if you want to check out another episode from the podcast, click right here.